Ramamurthy, Dr. Saxena,
Yes,
Okay,
yes,
from my side.
please go ahead. Yes.
Rajiv, all set?
Yeah, please.
IT section, ready? Dr. Yogmala?
You're not there.
No, she has not joined, I think.
Okay, recording has started. Right. Good morning, everybody, and welcome to the session on MSC at the second IMO mock session competition 2022. The topic today which we will discuss is MSC, safety and training aspects associated with various fuels being proposed. 31 teams from 6 IMU campuses and 5 affiliate institutes started the competition, and today the remaining 12 teams will battle it out for reaching the prizes. A panel of 4 extremely eminent judges are assessing the out-of-box thinking of our youth. We have Mr. M.V. Ramamurthy, who retired from Reliance Industries as President Shipping, a graduate in Mechanical Engineering, postgraduate in Shipbuilding and Naval Architecture. Mr. Ramamurthy is a past President of the Institute of Marine Engineers, India, and Honorary Fellow of the Company of Master Mariners of India. His rich and varied experience includes about 10 years as seagoing marine engineer, 8 years in shipbuilding, and 35 years in operation in shipping, liquid bulk handling terminals, and associate development and new building. Mr. Ramamurthy has been an Indian delegate to IMO MEPC meetings for several years and being part of it, working in correspondence groups. We thank you, sir, for agreeing to be a judge for this competition.
Okay.
Dr. B.K. Saxena, founder principal of Tolani Maritime Institute. He headed the institute in 2018 for a period of almost 20 years. Amongst his other passions are maritime law, chartering, shipbroking, arbitration, etc. He has represented India at the IMO and has been part of various IMO panels. Dr. Saxena remains even more busy after retirement than he was before. Mr. Dilip Mehrotra, a mariner of repute. He is a former Deputy Chief Surveyor to the Government of India and former Secretary of the Indian Ocean MOU, and a former President of the Institute of Marine Engineers India from 2015 to 2017. He is presently in Singapore, enjoying with family. Mr. Achintya Datta, a marine engineer from DMET 1983-87. He joined SCI as a 5th engineer and continued in service till 2002, about 15 years of service in various ranks. After 2 years ashore, he joined the DG Shipping in 2004 and continued till 2019 as Deputy Director General Tech. Presently, he is holding the responsibility of the Secretary with the Indian Ocean MOU Secretariat. He has represented India either as a member or as head of the Indian delegation on various sessions and meetings. Thank you, judges, for agreeing to join us on this program. The 4 teams today in Group 1, the 4 teams which qualified from Group 1, and these are teams A2, B1, C1, and E1, all from the Kolkata zone. Their guide is Captain Mahesh Yadav, an extra master. Captain Yadav is an alumnus of Rajendra, 1976, and has more than 30 years experience in maritime training. In 2010, he was awarded for outstanding contribution to maritime education and training on the National Maritime Day. He participated in all IMO STCW revision meetings from 2007 to 2010 and was chairman of the STCW 2010 Implementation Committee appointed by the DG Shipping. He presently looks after all training institutes of COSMA in addition to performing other association functions. I now call upon, thank you Captain Yadav for being a mentor to our young cadets. I now call upon Mr. Rajiv Nayyar, who will chair the various technical sessions today, and the person who has conceptualized this event from scratch. Over to you, Rajiv.
Thank you very much, Gaurav. A very good morning. Good morning to the judges. Good morning to the guides. Good morning to the coordinators, zonal campus, and good morning, delegates, and all other students who are watching this session. I hope you are able to take something away from these sessions. So, I'll just give a brief before I actually commence the session for the benefit of those who are participating as delegates today in these sessions. The way we will proceed is that in each group, we will give 8 minutes for you to present your paper. Thereafter, you can go up till a couple of minutes more, but please be aware that there are negative marks if you exceed 9 minutes, and at 11 minutes we'll stop you. So please be brief and make sure that you finish in time. Thereafter, you would have interventions of the floor from the teams of your group participating in that, to which you would get an opportunity to respond if the interventions require a response from your end. The judges will be observing all your presentation as well as the interventions from the other groups, as well as your responses to the interventions. So please be factual, correct to the point, so that uh, I think one important point is please do not try to give any incorrect information across, because learned judges are very well aware of the rules, regulations. So incorrect statements would not go well with the judges as well as the other members who are listening to the participation. So please do respond correctly. Uh, we look forward to a participative interaction from all of you. And with these few words, one point I would say that as chair of the session, I would have the right to intervene at any time. The judges, of course, also have that right to intervene at any time if there's a particular point they wish to raise. Rest, you will request it, except for those who are presenting and speaking, to keep yourself on mute. When you require to speak as an intervention or as a point you want to raise amongst the group which you are participating in, please raise your hand and I will call upon you. Once I call upon you, please unmute yourself and make your point. With these few words of do's and don'ts, I will now put on my hat of the chair of the session. So very good morning, delegates. Welcome to this first session on MSc oriented topic, and I look forward to your participative interaction in this session. I now call upon Kolkata A2 to take the floor and introduce their paper. Kolkata A2, the floor is yours.
A very warm good morning to all the chairperson, the respectable judges, honorable delegates, and the audience present here. I, Cadet Anadium, along with my teammates from A2 Kolkata Zone, are here to present our paper on the topic Assessment of Risk related to the use of LNG as a marine fuel and suggestions to limit those risks. We have divided the whole paper into various sections. To begin with, we have presented the requirement of a substitute for HFO, followed by why we choose LNG from all the other available alternative fuels, the research methods, and the safety issues regarding the use of LNG as a maritime fuel will be discussed and will be followed by the topic LNG bunkering, which we found as the most pressing issues among the rest. We will be mentioning our research procedure, the observations made, and we will be concluding with the solutions for the issue. As we know, after the introduction of MARPOL and excess, several changes have been made to the regulation which force the industry to look into alternatives which may be either propulsion or the fuel. In our paper, we have discussed LNG, the fuel which keeps the efficiency to reduce carbon dioxide by 15% along with the reduction of various gases such as NOx and NOx to a great extent. Heavy fuel oil has been the main fuel used in the maritime industry for a really long time, as it is the most affordable and accessible fuel. With the rising demand, we must consider the safety concerns presented by LNG. Our paper looks into the problems and offers suggestions to improve the LNG fuel safety. Our research was conducted mainly based on 3 steps, which are 1. Can we really replace HFO with LNG? If so, why LNG and not any other alternative fuel? 2. If we can replace it with LNG, what can be the safety concerns on doing so? And 3. How can we tackle these issues and how practical are those? Now, I request Cadet Rustam Raj to take on the presentation from me.
So, why LNG? As we know that after the restrictions of the sulfur emissions, mainly in sulfur controlled areas, Hfo is mainly facing many back. So, as my colleague has already discussed that LNG decreases the emissions of SO2 up to a great extent. Now, we have done the comparative test among all the fuels on 7 scales like ability, safety, cost, and among all these, LNG come as a excellent option for us. We can see that from this table, like we have coal, but the environment impact of the coal is very bad as compared to LNG as well as other fuels. Whereas biodiesel is also good, but the main problem with it is the storage as well as the cost. Now coming to the cost, like we have already discussed, LNG is one of the
Coming to the cost barrier, we know that LNG as a fuel used to be very expensive long ago, but with the newfound sources of LNG worldwide, now the LNG prices have dropped significantly, whereas the HFO prices have risen as a result of increased use of fossil fuel and the comparatively lower availability. It is meant to sustain for a long time, but that long time is not that long. Also, an LNG has a cheaper cost per ton when compared to HFO. We need less fuel to produce more energy. This ultimately cuts down the costs. Also, combining results from a variety of sources across the world, a study shows that LNG has a remarkably lower impact on the environment compared to HFO. As you can see in the diagram here, the graph, it shows that the pollutants which are emitted by LNG are very, very lower compared to HFO. Okay, so what are the safety concerns regarding use of LNG as a marine fuel? As you know, all good things come with a catch. So the first is an inexperienced crew. As it is a newer technology, relatively newer technology, not many crew are familiar with handling LNG, and it is a very volatile fuel, so you have to handle it properly. The second is embrittlement due to the gas. The gas corrodes the metal which it is stored in. The third is hot vapor release. In case of an LNG leak, vapors are released and these vapors can explode, which is a huge concern for life and property. And the fourth is leaks during LNG bunkering. Bunkering is one of the operations. As you can see in the other slide, LNG is supplied to ships using bunkering, and it is one of the most accident prone areas, as it has not been there, not regulations put into place which can minimize the loss of property and life. It is done into 4 steps. And coming to a research procedure cuts it down into 5 parts: assessing and providing solutions. The first is data collection. Data collection is designed to complete the process of collecting and measuring the vessel and port information throughout a survey, which is based on the port of Norway. The second was scenario analysis. Now we know the contributors which contribute to the accident, which is the leak size, the leak direction, and wind direction. So we combine those to form different scenarios in which accidents can take place. The third is frequency analysis. Okay, an accident has happened, but how often does it happen? That's how big of a threat it is. So the first is leak hole. We combine three various factors to produce the number of scenarios. First is leak holes. Then we combine it with hole direction. And the third with wind direction, because the wind direction will determine whether it will go towards the sea or towards the population or equipment, whatever that is. The next part, which is the most critical part of our paper, is the impact analysis. Now, as you can see the equation on the screen, we use this equation to assess what is the impact of a leak on property and life. Now, the IGF code, which is the International Code of Safety for Ships Using Gases. This code is implemented by many flag states, but it does not have any specific safety requirements for a safety zone. So we can reduce or minimize or even eliminate the risk on life. With this in mind, there are still drawbacks based on the fact that there are different levels of safety requirements set. Not all of them are optimal and ideal. So in this paper, we use two criteria to assess the risks. The first is half LFL equivalent to 2.5% of airborne gas concentration by volume. And the second one is a little extreme, but we have to put in the extreme scenarios. It is full LFL equivalent to 5% of airborne gas concentration by volume. And the last part of our study was focused on risk assessment. We have all the data, we have combined everything. Now we know what are the risks associated with an LNG bunkering accident. So it was done in two parts. First was PIDA, which is population independent analysis. There are no people around, an accident happens. Let's see how much damage it creates and what can be put into place to stop that. The second was PDA, which is population dependent analysis. Because PIDA has some pitfalls in determining the appropriate level of safety zones. So we have to put in some people and see how it performs. So what did we observe? We observed from all our study combined that appropriate levels of safe zones can be set at 28.8 meters, which can greatly reduce the amount of damage to property, as well as we are focusing on mainly people here. Property can come back, people can't. So at the risk of one fatal incident in 10,000 years, a safe zone at 28.8 meters can be set. Whereas at 46.6 meters and 213 meters, the areas are within 5% and higher gas concentration, regarded as the critical zone. The second part is, in case of critical area considered to be within 2.5% and higher gas concentration in air, the safety zone will expand to 34.9 meters because the gas, it spreads. So, concluding our study, what recommendations do we have? So we know that while several studies on safety of LNG powered vessels, both qualitative and quantitative, have been carried out in the past decade since LNG has been used as a fuel, many flag states and ports, they don't have that much data and they struggle to confirm the correct level of safe zones when extracting LNG. This leads to fatal accidents, this leads to losses, which is not good in current scenario. So in our research, we concluded that the level of risk associated with LNG bunkering and a safety distance of 20 to 30 meters should be placed to prevent any adverse event. Now, every flag state has to choose for themselves, but if it is between 20 to 30 meters, then we think it is optimal and it greatly reduces the risks. Now, the organization may take into account the above paragraph as well as some other safety concerns which are expressed in our paper but not mentioned here due to time constraint, and incorporate them in any future guidelines for using LNG as a fuel for ships.
Thank you, Hfo Calcutta, for sharing your research. I assume you have
Now,
concluded.
we would like to thank the judges and all the delegates for giving their time, hearing to us, and giving us this opportunity to speak on our paper. Thank you.
Thank you, Hfo Calcutta. Maybe you were waiting for your last slide to appear. Okay, thank you for sharing your research with the gathering, and I now open the floor for comments from any of the other member states. You can please unshare your screen. I see the card of C2 Kolkata up. C2 Kolkata, please.
Thank you, Chairperson, for giving me the floor. First of all, I would like to appreciate the effort put in by the delegates of A2, and I'm curious about why they have chosen Port of Norway for their particular research.
Thank you, C2, for your query. Would you like to respond to that, A2?
Yes, sir. So we have chosen the port of Norway because the DNV failure database, it clearly mentions Norway, and there are a lot of studies and research that Norway puts into its programs. So we had a lot of data to work with. We knew exactly what we were going for, and so we could produce quality results, which can be reciprocated worldwide.
And it would be helpful, A2, if you could share the sort of volume of LNG which traverses the port of Norway. Possibly what member state C2 is looking for is what is the base on which this study has been done. So the volumes would help them. So in future, if you could share the quantum of LNG which traverses across Norway's ports, it would be helpful for other member states.
Yes, sir.
I see no other member state having their card up. In case any non-member state wishes to say anything, kindly put it on the chat box so that I am unable to see it and decide if it can be taken up in the forum. Thank you, because this meeting is for the member states. I see no further cards up, so I'm going to ask Kolkata B1 to take the floor.
Sorry for the interruption. I saw some card was somebody has raised hand from Kochi, some faculty. I think he would like to share something. Arvind.
That was my request. That was my request. If you have something urgent, please do put it on the chat.
Very good morning, chairs and all the participants.
Dr. Arvind, is there something related to this or?
Yeah, related to this, I have one question.
Sorry, if you could put it in the chat box because this is limited to the member states. If it's a question, if you have something about the campus, some team participation, then you please go ahead.
No, the theme he has presented. May I know the, he has presented one, a model.
If it's a technical question, please put it in the chat box because we'll like this to be limited to the member states participating. Thank you. Kolkata B1, the floor is yours.
Very good morning, everyone. I am Cadet Sonal along with my teammates, Cadet Rahul Singh and Cadet Rohit Kumar in annual mock session on the topic, development of further measures regarding safe use of methanol as fuel on board ship. So going on to the outline of the paper, the content basically covers how methanol perform as a better marine fuel, its issues related to safety and the precaution while handling fuel on board ship, with the amendments in SOLAS regulation to fight the problems faced while using fuels with low flash point. Moreover, the paper also shed light on fuel cells and carbon capture system. Going on to methanol as marine fuel, methanol has emissions that are on par with LNG, but it is far less expensive to modify engines and has access to infrastructure because it is currently being used on ships and it is supplied by almost 100 ports worldwide. Overall, the gasoline is practical in every way and offers a viable alternative fuel at this difficult time in the economy. When we are talking about the advantages, methanol burns cleanly and releases less smog-causing pollutants, particulate matter, when compared to conventional fuels. It can help ships meet eco-friendly fuel standards, improve the quality of the air, and solve related issues with human health. When talking about the worldwide availability of methanol, Methanol is one of the top 5 chemical compounds sent over the world each year. With very minor improvements to the terminal infrastructure, it may already be utilized for bunkering worldwide, unlike other alternative fuels. Moreover, methanol proved to have a remarkable history of safe handling, and it is biodegradable. Handling of fuel. The following instructions must be written on the label of the gasoline sample, receiving the vessel's IMO number and name, the bunkering port, used sampling technique, fuel oil quality, owner's name and signature. Problems involving adulteration of gasoline to increase volume during transportation may be resolved this way. Although it might be challenging to track the supply chain at each stage, the quality of the fuel can be monitored on a frequent basis as it is moved from one location to the other. The majority of issues with the fuel splash point may be addressed by inner gas system, SOLAS rules, and IMO-approved safety regulations. When debunkering is concerned, it is basically based on the restrictions imposed by states. Moving on to the next slide of methanol bunkering. As methanol contains no sulfur at all, this whole problem is completely avoided. The toxicity of methanol, along with its low flash point of 12 degrees Celsius, necessitates special management during storage handling and usage in addition to material compatibility concerns. A methanol marine fuel grade definition is currently being developed by ISO, however, it is not yet accessible. Fuel bunkering stations. Following are the precautions needed to be taken for fuel bunkering stations. Sufficient ventilation should be provided to the bunkering station. It should be separated from other areas of ship by gas tight bulkhead, and control of bunkering should be done from safe location where tank level can be monitored. And for fuel bunkering system, manually operated stop valves and remote operated shutdown valves should be present in every bunkering line close to shore connecting point. Bunkering pipes should be self-draining and bunkering lines be arranged for inerting and gas free. Connecting couple for transfer hose should automatically close at disconnection. When we are going to the benefits of using fuel cell, the following benefits that can be obtained by using a methanol reformer system with a high temperature polymer electrolyte membrane fuel cell and a carbon dioxide collection and liquefaction system to produce electricity. Compared to direct methanol fuel cell, it is more efficient and long lasting, and it can run on fuel on low purity, which reduces its cost. As a result of operating at high temperatures, numerous steps of the fuel processing are eliminated. When we are going to the working, the system includes a methanol steam reformer to produce reformate gas, a combustor to heat the reformer, an HTPEMFC stack to produce electricity, a CO2 capture unit, and a liquefaction system. Steam reforming is preferred because it can provide low carbon monoxide ratios, lower temperature reaction in the reformer, and a larger molar flow rate of hydrogen. The steam produced at HTPEMFC preheats the methanol-water combination, which is then evaporated by reformate gas stream from the reformer, mostly producing hydrogen. Then reformate gas is utilized to generate electricity in HTPEMFC, and off gas from the fuel cell is sent to the combustion chamber to generate heat, and by compressing and liquefying captured carbon dioxide. There are several precautions while using the same. According to a study that has been appeared in the International Journal of Hydrogen Energy, the gradient in water concentration between the anode and cathode has a significant role to play in water transport over the PBI membrane. As a result, cathode air humidification lowers the whole cell's ohmic resistance. Due to the large platinum content employed in these cells, recycling is required. In the future, platinum-free electrodes may be utilized as an alternative. Going to the next slide of carbon capture, energy converter, different carbon capture methods has been developed. However, there are still a lot of technical and economical challenges. Energy converters that produce power electrochemically include fuel cells. So today, several fuel cells designs are seen as an effective approach to capture the transform of carbon dioxide. Among the many different forms of fuel cell, microbial, solid oxide, and molten carbonate fuel cells have all demonstrated promising results in this field. When paired with power, the electrolyte in high temperature fuel cell like SOFCs and MCFCs is effective for absorbing carbon dioxide and has shown positive results. Coming to the conclusion, The challenges raised in the paper are intended to enhance fuel quality in the maritime industry. It also draws attention to related safety concerns and potential solutions that, if implemented, can reduce greenhouse gas emission, ensure the crew's safety while on board, increasing operational cost effectiveness, opening pathways for future fuels, and increasing fuel cell utilization. The organization is urged to consider the aforementioned advantages as well as the safety issues surrounding methanol as a fuel and related safety measures when creating the update standards in the methanol chapter at IGF code. Thank you.
Thank you very much, B1 Kolkata, and your suggestion for having a methanol chapter in the IGF code. I will take that forward in my summary, and meanwhile, I open the floor for discussions. C2 Kolkata. Before I let you speak, I think I had made it very clear in my introduction. The forum is open for the participants of the session. I see a card of C1 Chennai up. Please wait for your session to start. I do not think you are part of this session, are you? Thank you very much for letting the flow of the event go on. C2 Kolkata, please, the floor is yours.
Thank you, Chairperson, sir, for giving this opportunity to speak. And my question for team B1, Kolkata is, as the energy density of methanol and LNG are near to similar, what are the reasons for the team to prefer methanol over LNG?
Thank you. C2, would you like to respond, B1 Kolkata?
Yes, sir. I am Cadet Rohit Kumar from Team B1 MSC, and I would like to respond to this question.
Go ahead,
So,
please.
as Sir said, that although LNG and methanol have the same energy density, however, methanol requires less storage space and is more economically feasible for use. Also, when combined with the fuel cell, the power conversion efficiency of methanol is increased many times. So we can say in this way, we preferred methanol over LNG.
Thank you, B1, for your clarification. And I suppose you could later on have detailed technical discussion on the pros and cons of LNG versus methanol during a break and collaborate on that. I see
Excuse me, sir.
I see the card of A2 Kolkata up. You want to add something, A2 Kolkata? A2
Thank you for
Kolkata,
the
the floor is
presentation.
yours. Yeah.
Yes, sir. Sir, I have a question for team B1. Like the disadvantage of methanol is still overweight the advantages. So how do you propose it as a better option?
Okay. So, in our opinion, and as per our report, the only disadvantage that methanol is currently facing is its unpopularity right now, as the LNG already has infrastructure and there are still a lot of developments going on in LNG. However, in case of methanol, it has a very negligible carbon footprint, as methanol can be made from renewable resources. It is cheaper than LNG. It has no problem of methane slip. It is easier to handle and store than LNG, and the cost of modifications, whether in a retrofit or even if we make a new build, is very less as compared to that of LNG. So I guess for these reasons, we have chosen methanol over LNG, although it might seem like presently there are more disadvantages, but if we proceed in this direction, then I'm quite sure that in future methanol will be a very good fuel.
Thank you for your clarification, Kolkata B1, which I'm sure A2 has taken on board. I see no further cards on the table. Seeing no further cards from anybody raised, I will now invite Kolkata C2 to take the floor.
A very good morning to Chairperson Sir and all my fellow delegates present here today. The first four-stroke marine engine using heavy fuel was made operational in the 1930s. With time, shipping companies started investing more in research and development, and the two-stroke engine became bigger, powerful, and more famous. The usage of fuel oil is an operation with the potential to affect the safety of the ship or cause pollution. This calls for the need to develop further measures to enhance the safety of ships related to the use of fuel oil. Now, let us understand what the problems are. Safety of the ships is compromised when tanks overflow as they start to fill up too much. The oil is discharged from the tank air vent and flows into a containment box, which then spills out on the deck. If the oil accumulates on the deck, it may overflow if the guttering is raised at the deck edge. This is when the real trouble starts. Oil flows down the ship's side and onto the water surface, which then can be distributed widely by river or sea currents, going onto oil's port structure or other shore features and amenities. The other problem is the temperature. Of the petroleum products usually have a high thermal expansion rate, which must be taken into account when several thousands of tons are transferred or purchased. The barge will often try to under-declare the temperature during the opening gauge and over-declare during the closing. This is why the sounding of barge tanks is necessary to make sure that the correct sounding or ullage tables are used. Let us now understand the Capacitor effect and how it compromises safety during the bunkering of fuel oil. It essentially may be described as a frothing bubbling effect caused by compressed air blown through the delivery hose. The aerated bunkers, when sounded, will give the impression that the fuel is delivered as ordered. In fact, after some time, when the entrapped air in suspension settles out of the fuel oil, the oil level drops and perhaps compromises the journey calculations. In large bunker deliveries, this could be considerable, huge financial losses.
When we talk about the causes of problems, the main causes of these hazards can be divided into two types: human errors and machinery malfunctions. Hazardous incidents include human errors like failure to properly set up the pipeline system valves, failure to diligently monitor tank levels during the bunkering, and transfer of bunker at an excessive rate or pressure. This could put the whole operation beyond its desired limits and also increase operational stress on the crew. Bunkering is a common operation, but it's important that it's done correctly so the crew can maintain safety. The procedure must be followed correctly to keep everyone safe. While the vast majority of the bunker transfer operations are safely carried out without incident, it's very rare that things go wrong. Loss of containment due to an overfilled tank, a pipeline leak, or a faulty transfer hoses can result in oil spilling overboard, marine pollution, and may compromise the safety of the whole crew. The machinery malfunction of hazards include airlock, where air becomes trapped in the tank due to excessive pumping rate, trim, or list, causing a sudden unexpected discharge of mist or oil from the tank ventilator. Also, malfunctioning of valves associated with deficient valve testing or maintenance are the root causes of all types of danger related to bunkering and fuel oil usage.
The delegates of C2 propose the following solutions. First is the use of alternative fuel. But first let us understand why HFO is on the decline. Diesel fuel contains sulfur, which derives from the original crude oil source and can still be present after refining. After combustion, sulfur from diesel fuel creates sulfuric acid that causes corrosive wear on the metal surfaces of an engine. The sulfur in fuel forms particulates that are a primary contributor to air pollution, and thus IMO implemented regulations regarding the sulfur cap. Commonly termed as the Sulfur 2020 rule, it lowered the previously allowed limit of 3.5% to 0.5% mass by mass for sulfur in fuel used on ships operating outside the designated emission control areas. This alteration led to modification of Annex 6 of the International Convention for Prevention of Pollution from Ships, that is, MARPOL, making this new limit obligatory. An important step was taken to reinforce the air quality to guard the environment and safeguard human health when a brand new limit on the number of sulfur in fuel used on ships went into effect on 1st January 2020 by the IMO. While numerous alternative fuels with lower or zero carbon emissions could help achieve the IMO's 2030 and 2050 gas reduction targets, many of those replacements still require extensive development to satisfy industry requirements. While laying the groundwork for lower or carbon neutral fuels produced from renewable or zero carbon energy at a time when the entire world is under substantial pressure to require action to scale back GHG and other emissions to air. Our paper asserts that LNG may be a solution that may help the industry advance. The study evaluated the operational and commercial viability of 6 of the most alternative fuels, including hydrogen, ammonia, methanol, LPG, biofuel within the type of hydrotreated edible fat and fuel battery electric systems. The root cause of most hazards in the usage of fuel oil lies in unsafe bunkering. As a remedy, STCW course should be implemented at the basic level of training course. Practical tasks assigned with help in following ways: properly set up pipeline system valves, diligently monitor tank levels during bunkering, avoid transfer of bunkers at an excessive rate or pressure. A representative sample would be obtained by a permanent sampling probe fitted close to the bunkering manifold. Onboard testing of the fuel could be carried out during the bunkering operation by one of the engineers not required to supervise or monitor the bunkering operation. The following tests could be carried out: water content, viscosity, density, compatibility, and a check for abrasive fines. Although the tests are not as accurate as a shore-based lab, the test would indicate whether the fuel loaded is the same as the fuel quality ordered and therefore the bunker received.
We believe, as delegates of C2, there is a need for collaboration between MSC and MEPC. The Maritime Safety Committee deals with all matters associated with maritime safety and maritime security, which fall within the scope of International Maritime Organization, covering both passenger ships and cargo ships. The MEPC addresses environmental issues under IMO's remit, including the control and prevention of pollution from ships covered by the MARPOL Convention, and also the oil, chemicals carried in the bulk, sewage, garbage, and emissions from ships, including air pollutants and greenhouse emissions. Equally important is changing norms and expectations within the sector and cooperation between ship owners and operators and maritime authorities. To ensure such compliance with maritime regulations requires continuous monitoring and collaboration between MEPC and MSC. With this, we conclude with our suggestions. We open to further questions.
Thank you very much, and for highlighting LNG is your way forward and the need to do some amendments in SCCW model courses possibly, and also highlighting the need for, on this technical topic, of collaboration. I open the floor for interventions. I see the card of B1 Kolkata. B1 Kolkata, the floor is yours.
Thank you, sir. Good morning to one and all present here. And my question to Team C2 is, as the paper was convincing as how LNG is preferred, to be used as a fuel. I'm curious to know, is HFO still a viable option?
Would you like to respond, Kolkata C2, and could you please unshare your screen? Thank you.
Yes, sir. I would like to answer the question, sir.
Please go ahead.
Yes, sir. As HFO, being a very cheap fuel, can still be a viable option in the shipping industry. But way forward, we look in a future where there is no sulfur in the fuel oil. For that, we have preferred LNG, and with the purpose to remove any SOx emissions from the combustion of fuel oil. But case in point, HFO still being a very cheap fuel, there is still a requirement for HFO in the maritime industry, sir.
Thank you, and that possibly also stresses the point of a need for collaboration between MEPC and MSC on this very relevant topic. I see no further cards on the table. Oh, yes. A2 Kolkata, the floor is yours.
Thank you for the opportunity, sir. So my question is that what role does a bunker delivery note play in the safety of ship and avoiding hazards?
Is your question specifically to C2 because they want to respond on bunker delivery note, or is it a specific question which you would like a secretariat to answer? C2, would you like to take that?
Yes, I would like to take this up, sir.
Okay, go ahead.
So our bunker delivery note obviously gives a very useful information on quality and quantity of the fuel delivered. Perhaps that the convention of STCW and its model courses, just how we have mentioned it in our paper, perhaps we can include it in the training courses, how to check and verify BDN. It gives data like sulfur content, density of fuel, water content, etc. So if quality of fuel is not matched, it could be a fatal incident for the ship. So BDN is a document which proves to be very valuable in the whole operation of bunkering and usage of fuel oil.
Thank you, C2. And yes, as Secretariat, we can also share that we have received information from some member states who are sort of making bunker delivery notes become under the purview of the administration in electronic format for tracking as well as being able to take steps on it. So thank you, C2, on that. Even your hand is up. You may take the floor.
Thank you, sir. So the C2 mentioned that uh, during bunkering, we see something called the Capuchino effect. So my question is, how can we as marine engineers, how can we avoid the Capuchino effect from distinguish between the good bunkering fuel and the one which is being tarnished?
Okay, even maybe these technical aspects you can take over as a marine engineer to marine engineer over a coffee break. As a member state, is there something you want to highlight?
Yeah, yes, sir. This is the question. How can we avoid it, sir?
Okay, C2, would you like to respond on Capuchino effect?
Sir, I would like to take this up with your permission, sir.
Okay, so I would request anybody who has any member state who has experiences from their vessel owners or something on Capuchino effect, if they have some technical research on that, share with it. Other member states are interested to know about it. It would be a helpful knowledge for people. With that, I assume even your card can be robbed, or you still have something to say? Thank you very much.
Yes, sir.
I now, what I can share with the knowledge which is with the Secretariat is Capuchino effect was something more related to quantity rather than quality, where impact on the value you saw of the fuel, and it was largely taken away with the introduction of flow meters. But I would not close it at that. Whichever member state has any other further information, technical information, is requested to put in papers so that other member states can benefit with respect to that. So I now request Kolkata E1 to take the floor and introduce their paper.
There are some issues with my camera.
Can you do your presentation, or are you having an issue with presenting?
I can present, sir.
Go ahead with the presentation.
Yes, sir. Sir, is the presentation visible?
Yes, it is visible. Please go ahead.
Good afternoon. I am Sayak Sen representing Team E1, and our paper emphasizes on how LNG can be used as an alternative marine fuel with close regard to safety aspects, accident modeling, risk assessment, incident reporting, and crew training. When it comes to LNG as an alternative fuel, this green fuel is witnessing rapid improvement in its bunker infrastructure. The benefits not only lie in its competitive prices, but also significantly reduces harmful emissions, improves air quality index, complies with regulations, and aligns with IMO's goals for GHG reductions in the long run. LNG-powered vessels have the potential to reduce the carbon intensity index and energy efficient design index by 20%, along with reductions in GHG emissions by 23%, NOx by 80%, and sulfur oxides. However, to safely extract the benefits of this alternative fuel, proper quantitative risk assessment and hazard identification is necessary. Before coming to the safe handling procedures of this alternative, it's important to know the different kinds of hazards LNG can pose under various conditions, as mentioned, which include flash fire, spill fire, jet fire, explosions, asphyxiations, brittle fracture, cryogenic burns, and so on. The hazards, their causes, and consequences can be classified with the help of the following flowchart. Accidental release of LNG can be broadly categorized into unignited hazards, immediate ignition, and delayed ignition. The table alongside helps in better understanding of the sources of fuel ignition like sparks, electricity, signals, radiations, shock waves, and so on, with some practical examples of their sources. Coming to the safe handling of the fuel, qualitative risk assessment is a technique shown alongside for defining risks associated with an operation, the severity of its impact, and the likelihood of its occurrence. Its essential elements include the hazard identification, risk management, consequence modeling, frequency estimation, and risk assessment. A risk criteria framework deals with the risks and measures to mitigate them based on factors like probability, severity, and the costs and benefits involved in the risk reduction. Another important aspect of safe handling of LNG involves determining control zones during operations like bunkering. In order to prevent accidental release or formation of combustible mixture, safety perimeters should be determined to permit only necessary personnel and activity. Based on proper evaluation, the perimeter can be classified into hazardous zones, safety zone, monitoring and security area, marine traffic exclusion zone, and finally, the external zone. And a proper definition of control zones call for a proper evaluation method, listed as follows. This may include a proper sequence of action involving calculating, planning, sharing, approving, implementation, and control. Another aspect of safe handling of LNG deals with simultaneous operations. that occur in parallel with bunker operations, leading to increased risks. These may include, but are not limited to, loading and unloading of cargo, lifting or maintenance work, passenger embarking and disembarking. And just like control zones, simultaneous operations also require a comprehensive risk assessment involving hazard and QRA. The flowchart alongside defines and summarizes the recommended process for analyzing risk of simultaneous operations in LNG. Our final aspect of LNG's safe handling deals with methane slip. LNG comprises of 85 to 95% of methane, which has a global warming potential 80 times more than that of carbon dioxide. This calls for proper countermeasures to ensure minimal escape of unburnt methane into the atmosphere from two-stroke and four-stroke engines. Causes of methane slip include crevices or pockets in combustion chamber, lean running conditions responsible for incomplete combustion, and leakage through piston rings. Some of the measures undertaken by MAN BMW for its two-stroke diesel fuel engines include injection of gaseous fuel when piston is at TDC, slightly after liquid fuel injection, which ensures efficient combustion, closing of exhaust valve before gaseous fuel injection, and hence checking methane escape, and ensuring no unburnt methane is trapped by maintaining high compression ratios. The following slide focuses on research and development for reducing methane slip in four-stroke engines, which includes minimizing the valve overlap, reducing the height of top land by raising piston ring positions, thus increasing combustion pressures and temperatures, implementing electronic control for accurate fuel quantity and timings, direct gas injection, and last but not the least, exhaust gas treatment. Finally, concluding, the paper has emphasized on the use of liquefied natural gas as an efficient alternative, complying with regulations and good for the environment, keeping in mind its various hazards and carrying out comprehensive risk assessments, proper crew training, and incident reporting to reap its benefits as a marine fuel.
Thank you very much, Evan. I now open the floor for interventions. A2 Kolkata, please go ahead.
Thank you, Chairperson, for giving me the opportunity to speak. First of all, I would like to say that I agree with Evan on regarding creating radius of control. It is very critical, and it has been gone by for so long without getting noticed. The question my question to Evan is, why is the study specific to LNG and not other fuels? Like, how did you arrive at LNG?
If I understand your question correctly, so that I can request Evan to respond, is you want to know is why only LNG they have picked up?
Yes, sir.
Is there, okay, Evan, you would like to respond to as why you have limited yourself to LNG?
Yes, Chairperson, sir. Thank you for the floor. Currently, 60% of the new builds which are ordered by 2023 are LNG powered and dual fuel vessels. Hence, we believe LNG is the rightful alternative.
Thank you. Thank you for clarifying that. Considering the order book, you feel it's a very relevant topic to take care of. Thank you. I see no further cards up. Okay. We normally take a break at this point when I try to sort of summarize my views and give a summary. Considering it's a Sunday, and I would like to see if we are doing good time. I am pleased to note that all the teams are adhering to the timelines well. Therefore, I'll try to summarize in a flow right now and only check up with the IMU backend team that if I go with the flow now, the next session is supposed to start at 11 o'clock. Considering half an hour for tea and my summarization in the next 2-3 minutes, is there a possibility of pulling back that session to 10:30 if the teams are ready? if they could in the back end check up so that we can announce that. Gaurav, could you check that aspect? Then we could have a half an hour break for tea and start at 10:30. Thank you, delegates, for your active participation, bringing about some very relevant topics. Both Kolkata A2 and E1 emphasized on LNG and the need of really looking at a risk assessment tool to be able to visualize the dangers associated with bunkering of this and the need to study the zones which are done and accordingly may look at amendments to the IGF code. I look forward to your further research on that and giving concrete proposals on what could be amended in the IGF code to take this into account so that these concrete proposals can then be considered, including the background which some member states had requested as about the strength of the database on which these observations have been based. Additionally, even did talk of methane slip, and that possibly supports what C2 had been talking of about a collaboration between MEPC and MSC, because now this is getting into technical details and it may not be limited to MEPC and MSC. It could also be involving the design committee, various other committees which are working on these sort of aspects to make sure that the technical aspects are fully understood, and accordingly we would put this up at the secretariat that a plan be formed so that these technical aspects could be taken off in a consolidation. C2 did bring about the necessity of training and amendment. As you may be aware, HTW code is under a possible review in the forthcoming time. It would be nice, considering the gap you have identified, if you could put up proposals where you could identify both in the convention as well as in the model courses content what could be added on to take care of the needs of the officers, able seafarers, everybody covered under the conventions who are part of the bunkering operations and also the day-to-day operations of usage of the fuel to take care of that. B1 did bring about regarding methanol and the need to introduce a methanol chapter in IGF code. I would request B1 to take this study further and give us a concrete proposal on what is requested to be added in the IGF code in terms of where it could be inserted and what could be done to take care that methanol as a forthcoming fuel. Though at the moment what we are aware is that there are vessels which are using methanol as fuel are majorly carrying methanol as a cargo. However, since in future this may become as a fuel, irrespective of the cargo you are carrying, it would be good to have your views so that a timely action of that would be in place. So with that, I declare this session closed. And I do see Gaurav checking up whether we are ready for 10:30. Accordingly, we will talk of the rejoining time of this session. Right now we are at 10:03. Gaurav or Dr. Yogmala, would you like to advise on that? Or do we keep it 11 o'clock?
Sir, I'm checking and I'll get back to you.
But we will not be able to advise the members who are online. So otherwise, we take a 1 hour break and get back at 11 o'clock to avoid any disruption.
Okay, sir. Okay, thank you.
Gaurav, unless you have something to add, then I'll close the session on that basis.
No, we'll check with the coordinators. We can tentatively keep 10:30. If they're not ready by then we can push it to 11.
I think it would be unfair to all the people watching. They will not come to know whether to join at 10:30 or 11.
Okay. Fine.
So unless the judges have a view, I'll keep it then at 11 o'clock and we can have a long tea break, maybe a long tea and coffee break. Mr. Ramamurthy.
I think Mr. Kaurav's suggestion is good. I think people will be prepared by 10:30. I think so. This one is too long. Dr. Sena is, of course, can say something on that.
Mr. Mehrotra has also.
10:30 you can come back.
Okay, so
Yeah.
Mr. Mehrotra.
Yeah, I'm on the same line. In 10:30, we'll all can come back. If they're not there, then we'll because everybody's at home or in the office. It hardly matters. It's okay.
Okay. I will then say that we are getting back at 10:30, and unless we hear an issue from the teams participating, we'll be commencing the next session at 10:30. I would request Dr. Yogmala and Gaurav to make sure that suitable messages are shot off on WhatsApp and email to the groups which have been invited for the sessions. Thank you. So 10:30, we come back on again.
Okay, sir.
Thank you.
Thank you. Thank you. The Indian Maritime University came into being through an Act of Parliament, Act 22, on November 14, 2008 as a central university and is poised to play a key role in the development of trained human resource for the maritime sector. The Indian Maritime University is in the category of professional university intended for fulfilling the requirements of the maritime sector. Ability to establish and develop a critical mass of activities in the maritime sector is the primary advantage of the IMU system. All activities need not be in a single location but should be distributed across different locations in the country, which have the comparative advantages to facilitate the best possible education and training in a given area of specialization. The structure and content of the programs leading to different levels of qualification of the personnel engaged in the maritime sector can be uniquely addressed by the IMU unconstrained by the limitations of the general-purpose universities. The upgradation of courses, revision of syllabi, introduction of new courses, adoption of new methods of technology, enabled learning, including regular classroom instruction, virtual classes, distance learning, etc., will be facilitated by the university system. The regulations governing the programs for various qualifications can be customized to meet the particular needs of the industry and the international organizations. Similarly, the university can develop its own transparent admission policy for its programs to cater to the profiles of the beneficiaries serving the maritime industry. Chennai Campus. Indian Maritime University, Chennai Campus, previously known as National Maritime Academy Campus, is located on a 20-acre scenic beachfront property on the outskirts of Chennai, a bustling cosmopolitan city. A 25-kilometer drive along the East Coast Road hugging the coastline takes onto the exquisitely designed edifice, an architectural marvel set amidst lush green sylvan surroundings. The sprawling campus houses the academic block, hostel, residential and recreational facilities. In IMU Chennai campus, we offers Bachelor's of Science in Nautical Science, B.Tech in Marine Engineering, Diploma in Nautical Science, MBA in Port and Shipping Management, MBA in International Transportation and Logistics Management, BBA in Logistics, Retailing and E-Commerce, Post-C, STCW courses. Kolkata Campus. The Indian Maritime University, Kolkata Campus comprises two premier institutions, the Marine Engineering and Research Institute, MARI, Kolkata, and the Indian Institute of Port Management, IIPM, Kolkata. After 63 years since its inception, MARI is regarded as the most acclaimed institute around the world for maritime education. In IMU Kolkata campus, we offers B.Tech in Marine Engineering, M.Tech in Marine Engineering and Management, MBA in International Transportation and Logistics Management, Navi Mumbai Campus. Indian Maritime University, Navi Mumbai Campus was formerly known as the training ship Chanakya. This campus came under Indian Maritime University in 2017. It was named as Navi Mumbai Campus. In IMU Navi Mumbai Campus we offers BSc Nautical Science, 1-year Diploma in Nautical Science, DNS, MSc in Commercial Shipping and Logistics, Advanced Firefighting Course, GMDSS course. Mumbai Port Campus. IMU Mumbai Port Campus is consisting of two premier maritime institutes of India.
Dr. Yugmala, can you update us? What is the status?
Sir, Kochi campus as well as Mumbai 1 and Mumbai 2, all 4 teams are ready, sir. You can start.
Oh, that is excellent. So we can start with all the 4 teams.
Yes, sir.
Gaurav, please go ahead.
I'm sorry, we have contacted 3 of the 4 teams. We have not been able to contact team A2 of Navi Mumbai campus. Neither we have been able to contact the zonal coordinator, Captain Muzumdar, no campus coordinator, Captain Farad. I have just requested their guide to try.
But I just let me interrupt you. I see the team A2 of Mumbai already checked in. A2 Mumbai, are you there?
Yes, sir. We are.
Very good, sir. We can start, sir.
Is it okay if we start at 10:30 with you, A2 Mumbai?
Sir, can we get 5 minutes? Just some technical problems.
Please go ahead. We will commence the session. Right now it is 10:32. We'll start at 10:38.
Yes, sir.
You can sort out your things by that time. Okay?
Yes, sir. Thank you.
Sir, I think we can announce about session 3, sir. Third session.
Affirmative. I would request Gaurav and yourself, if you could, in the meantime, coordinate if we could start session 3 at 12 noon, so that instead of having a lunch break, we try to finish before lunch. Being a Sunday, I hope that would be welcomed by all the participants.
Yeah, I'm trying.
So, looking at the timetable, if we start at 10:38, we will have a short break before the next session, and we'll start the session 3 at 12 noon. Could you coordinate with the campuses for session 3 and any other people who are interested? So we also don't want somebody joining in at 1 o'clock and realizing that everybody's gone off for lunch.
We are contacting.
Thank you. Is that okay with the judges? I do have judges' concurrence for this.
Yes.
Yeah. It's okay. Good. And session 3 has got 5 teams or 4 teams?
Negative, sir. But my last information of last night, there are 3 teams. One team from SIMS, I believe, was unable to join the program. I do not have a further confirmation, but maybe Dr. Yogmala or Gaurav have got any further update on that?
No. Let me see.
As far as I know, that was Mumbai 1 D2 team.
Mumbai 1 D2.
Mumbai 1 D2.
Yes, sir.
The last
yes,
one.
They backed off.
Okay.
They requested they could not participate.
Yes, sir.
So unless something changes, we have either 3 or 4 teams.
Yeah, okay, good.
So shall we start?
Gaurav?
Yes, team Alpha 2, are you ready?
Yes, sir.
Okay, very good. Welcome back, ladies
Yes.
and gentlemen. I will now introduce the four teams comprising Group 2 for this MSc session. We have Kochi B2 and D4. Mumbai Zone 1 has C2 and Mumbai Zone 2 has A2. The Kochi Zone guide for MSc is Captain Forrest Dalal, who has sailing experience of more than 15 years, with over 5 years in command, a doctorate in ship management from YSU University in USA. He is presently the head of fleet personnel at GFS Ship Management UAE. A popular guest and panel speaker, Captain Dalal is a member of the Royal Bombay Seafarers Society, and his experience and expertise makes him a popular speaker. Thank you very much, Captain Dalal, for giving your time and effort to mentor these young men and women. Mumbai Zone 2 guide for MSc is Mr. Ritesh Kaushik. He is a marine engineer and holder of breadth, an expert in international maritime law and techno-legal expert for shipping casualties and associated claims. Not a very common combination. Having successfully completed his master's degree in international maritime law from Southampton, he freelances for international firms across a broad spectrum of maritime law, including general average, salvage claims, marine commercial and industrial disputes, shipboard casualties, insurance contracts, hull and machinery claims, admiralty law, international commercial arbitration, etc. Has published numerous articles on marine insurance, commercial maritime law, maritime cyber risk law, and is currently co-authoring a book on maritime operations. Thank you, Mr. Kaushik, for giving your time and effort to mentor these young ladies and gentlemen. The guide for Mumbai Zone 1 is Mr. Sunil Kumar, a marine engineer from DMET 1993. He is also a master's in mechanical engineering and an MBA from IIT Bombay. Indeed, a very rare combination. He is presently heading the training and assessment department of Great Eastern Shipping and has also been a maritime surveyor and an auditor with DNB. He is a member of the Research and Training Committee of INSA and also a member of the Indian delegation representing HTW subcommittee at IMO. Thank you, Mr. Sunil Kumar, for sparing your valuable time and effort to train and guide these delegates. I now hand over to Mr. Rajiv Nayyar to take the program forward. Over to you, Rajiv.
Thank you very much. And now I commence with session 2 of the day. I welcome you delegates back to the forum, and I request Mumbai 2A2 to take the floor and introduce the paper.
Thank you, sir. So, good morning to all respected dignitaries and my fellow cadets from different campuses. I would like to thanks for this golden opportunity. So, as you know, our topic is cold flow property issue and problem associated with it in VLSFO ISO 8217-2020 and measures to deal with it. So, cold flow properties tells about the flow behavior of fuel oil in low temperature environment. As you can see, some of the cold flow property which are responsible for solidification of fuel in cold environment are cloud point, pour point, cold filter plugging point. So as you all know, cloud point is the temperature at which clouds started appearing in fuel. CFPP, which is cold filter plug point, is a temperature at which fuel fails to pass through the filter, and pour point is the temperature at which fuel solidifies or congeals. The VLSFO is a residual fuel oil produced by blending residual fuel oil with distillate fuel oil till it reaches the requirement of ISO 8217-2020. It has a high concentration of paraffin, as paraffin is more refined and a clean fuel oil.
Sorry
Divyansh,
to.
Divyansh, just hold on. I think one of the judges has an issue.
Yeah.
Mr. Datta,
Yes,
please.
Yeah, I just want to request the presenter to open the slide on slide mode because it is not showing. It's showing very small fonts.
Sorry, sir. Sorry. Yes,
Thank
sir.
you.
I'll do that.
Yeah, thank you. Go to the right corner down and put that slide icon
Yes,
on.
sir, I think there is a net issue. That's why I'm not able to just put that in the.
Okay, fine.
Sorry. 1 second, sir.
You can try putting off your video if you are having connectivity issues. I think if you're not able to resolve, then you continue like it is.
Just a second, sir. Just a second. Sir, I think it is not. I'm not able to.
Okay, go ahead. Go ahead.
Yes, sir. So I was talking about the VLSFO. So VLSFO is a residual fuel oil produced by blending the residual fuel oil with a distillate fuel oil till it reaches the requirement of ISO. It has a high concentration of paraffin, as paraffin is more refined and clean fuel, which ensures that it will produce a less soot, and the SO2 emission problem will be also low there. But there are some problem also associated with it, like you can see, that is higher wax problem, which chokes and damages the engine. So I would like to discuss the case study related to our topic, cold flow property issue. This we have taken from incident report of the latter vessel. So as you can see, this vessel MV Mineral Thamsi bunkered a grade of fuel oil RMG 380. The date you can see from the slide. Sample report of the bunker was also found as no anomalies, but as they started using this new bunker, their sludge discharge line of the oil separator got clogged frequently. So generating the separator fail alarm. One day, the engineer on duty received a separator N1 fail and fuel oil bowl leak alarm on the computer. Experiences learned that this was a consequence of contamination of the separator bowl 2. As the discharge line of the separator got clogged, the engineer informed the bridge and went alone to check the problem. While opening the inspection hole of the sludge discharge line, hot sludge gushed out of the inspection hole and covered the arm and leg of the engineer. So this was an accident. Talking about the cause of the accident, the official document states that the RMG 380 VLSFO cold flow property leads to the blockage of the sludge discharge line. And when this fuel separated at plus minus 40 degrees Celsius, the inspection plug was also the person, that is the oiler, he opened the inspection plug also very quickly. So that was also one of the reason. But apart from that, the cold flow property was also one of the reason as per the official document incident report of this vessel. So it should be noted that the time when accident occurred, the engine was operating at the temperature around 42 degrees Celsius and the discharge line temperature was around 40 degrees Celsius. As per the test carried out on the fuel, the pour point was observed to be 30 degrees Celsius, and as RMG 380 is a residual fuel oil, so its CFPP and cloud point was not measured as per the IMO requirement. That's not an IMO, but actually the ISO requirement. So it is not possible that CFPP of that specific blend was around 40 degrees Celsius, which causes a clogging of discharge line. Apart from this reason, there was also fault from engineer side as he was not wearing overall at the time of the accident. After this slide, I would like to call my friend Devang to take the further chart. So Devang.
Yes, sir. I will carry now further proposal. In this, the temperature management also provide an important role in cold flow properties. It is recommended that the fuels are stored at a temperature 10 degree more than pour point of the vessel. But heating should also kept to a maximum 40 degrees Celsius. So because above its fuel viscosity starts to give a problem. As we propose in our paper about adding additive to reduce the pour point and cold filter plugging point, because if a grade has a PP 30 degrees Celsius and CFPP near 40 degrees Celsius, then chances might be there of clogging in spite the fuel temperature is 10 degree more than pour point. By adding the additive, we reduce the pour point and CFPP so that around 40 degrees Celsius, no issues will be rising. Now we come to the VLSFO. In this, we know that VLSFO contains more saturated content, or we can say paraffin content. That is, it is more waxy fuel. By the graph, we can see that grades of VLSFO, which is given in a blue color, and having less viscosity and higher pour point, as compared to the heavy sulfur fuel oil, which is given in a red color. So basically, as described by my teammate, that the cold filter plugging point and pour point is basically minimum temperature, which tells us a limitation of a fuel. So to treat the cold field properties of this fuel, we can add an effective additive so that temperature of a pour point and CFPP reduces and ship can even travel at a cold climate. So the effective additives can help to reduce the temperature. So I come to the next point. This test carried out by the company was to check whether additive is working or not. Firstly, here there is a graph in which there is a pour point. First pour point additive was added to a fuel and the pour point of the fuel reduced as we can see in the graph. Then an additive is to treat a CFPP of the fuel was added. CFPP of the fuel was came down into to understood by the graph. But the main thing is to notice that CFPP additive was not only CFPP, but also the pour point of the fuel was affected and get reduced. Means when we are trying to sort the issue of pour point, when we are adding an additive for pour point, the CFPP does not get that much of help. But when we try to resolve the problem for CFPP, we will try to improve it, then pour point also get improved by this. Then this is basically a positive result. The formation of wax will start a lower temperature than before, and ships can be able to navigate through the colder region also.
Now I come to my next point, that is pre-flow. The pre-flow is nothing but an super concentrated anti-gel treatment, which makes the fuel flow in cold weather condition also. It basically reduces the temperature at which the crystallization occur and fuel filters are plugged. By treating CFPP, by treating the CFPP, it is nothing but it changes the morphology of the wax. So it will make into a finer particles, so it can easily go out from the fuel filters. So it can easily pass from that. So this is an advantage of using pre-flow. In table, we can see that there are proportions given, that how much proportions we can add to improve the fuel. If we add 1 liter of pre-flow, then about 2000 liter of fuel will be the most effective result. But for economically, we have to think for a larger amount. For that purpose, even if we add 1 liter of the pre-flow, then also we can almost 20,000 liter of fuel which can be reduced to its pour point. So by properly treating the fuel with pre-flow, we continue to safely use the fuel at temperature where it could normally chill or get crystallized. Now, whenever a vessel takes a new bunker, it has some requirement as per ISO, like viscosity, density, etc. Cold flow property is one of the requirement, but for a residual fuel, only pour point needed to be checked. But we believe CFPP of the fuel should also considered and added in the treatment of fuel standard for marine residual fuel. Now, I would like to end my presentation by this last proposal. As we know, LSFO is a new type of a fuel, and it has made by a mixing and blending to comply to IMO 2020 sulfur emission limitation. But this process, it starts to have different issues like cold flow properties. So we solicit that all seafarers must have a special training to properly handle this fuel, as this fuel is new, and we are trying to add some new points for that, and we are trying to make it more advantageous for ourselves. Therefore, we are trying to have some more special training to properly handle this field. Thank you, sir.
Thank you very much, Mumbai 2A2. I now open the floor for interventions. You can unshare your screen, please. Any of the other member states want to ask anything of Mumbai 2A2? I see there are no comments on the paper. Okay.
I thought C2 had a...
No, I just saw D4 has raised a hand.
Okay.
D4, Kochi, your hand is up.
Yes, sir.
D4, Kochi, you can go ahead.
Thank you for the opportunity, sir. I like to ask a questions. If we add additives to the fuel also, there may a chance of it can cause damage to engine also, sir. May I know what are the additives they can add to?
Okay. Mumbai A2, could you clarify if any research has been done at your end regarding the additives proposed by you and some pre-flow, if they impact the engines in any way, and if it has been done in future, if you could share it in a written format also. A2, would you like to respond?
Yes, sir. Yes, I would like to respond the
Please
question asked by D4.
Yeah, please go ahead.
What D4 said that the engine will be affected due to additives, but according to the test done by the companies, they said that no effect is on the engines. So the additive will not have any hazardous effect or a bad effect on the engine.
Thank you, A2. And if you could share some of those literature with the other member states, it would be helpful.
Yes, sir. Yes, sir. I will do it.
Thank you. I see no further cards. Considering that I do see somebody as a 8567 I assume you are not a participant, so if that is the case, it is okay. If you are a participant, you require to change your name nomenclature, otherwise you will not be able to recognize who you are. I now invite Kochi B2 to kindly take the floor and introduce their paper.
A very good morning to our honorable chairperson, delegates from the member states and other dignitaries. And thank you to the chairperson for giving us the opportunities to give a proposal in IMO MSC. We are delegates from B2 Kochi and we are going to present the developed nations. And our topic of our proposal is use of methanol as an alternative fuel and safety on board ships. So would, uh, would you give us the permission to present our PPT?
Please go ahead.
Thank you, sir. So here we are. We have four delegates: Devika Sanjit, Faris, Jay, myself, and Vinayak. We are the all four members. Our introduction is like we recognize all the ships fuels have with CO2 emissions that are highly damaging to the environment, and steps have been taken by everyone to reduce this. But methanol is a fuel that can be used as an alternative fuel due to its safety and availability. Methanol is blended with gasoline in low quantities and used in existing vehicles, or it can be used in high proportion blends such as M85 in flex fuel vehicles or M100 in dedicated methanol fueled vehicles as a substitute for gasoline or diesel. However, the main benefits of methanol can be low emission fuel. They are economical. They are available worldwide. They have a long history of safe handling. They are biodegradable, and they are made from various sources, including renewables. There is very few disadvantages of methanol that are which are formaldehydes emissions are higher. Then the cost of methanol is also a bit higher than the premium gasolines. Our proposal to to you is methanol is available worldwide through existing global infrastructure, so its use can be easily promoted as the cost to its build new and convert existing vehicles to run on methanol is significantly less than alternative fuel conversions. Our second proposal is from an environmental point of view, methanol performs well. Methanol readily dissolves in water and is biodegraded rapidly, as most of the microorganisms have the ability to oxidize methanol. In practice, this means that the environmental effects of a large spill would be much lower than an equivalent oil spill. Methanol bunkering is a safe and realistic option as a clean burning fuel with a sustainable pathway. Our third proposal is the rules that can be applied today as risk-based, meaning that there is need for a risk assessment for each installations. Methanol increases contaminations and being corroded by the heat. So care must be taken in handling methanol, adding hydroxide, mixing hydroxide, and then introducing the methoxide into the waste oil. Temperature control throughout the process is critical to be safe and efficient operations. So our action to the committee is, as per the proposal, it is clear that methanol is one of the newest fuel in shipping industry and there is no guidelines to use methanols. Therefore, the committee is requested to introduce guidelines on the use of methanol. Then there is a storage and transport of methanol should be regulated through more bunker facilities. Thank you so much.
Thank you very much, Kochi B2, for introducing methanol. You could unshare your screen.
Thank you, sir.
And I now open the floor for interventions. D4 Kochi, you have the floor.
Thank you, sir. This is Flavius from T4, and what they proposed was it is safe while using methanol. So, how safe it is for the ships? That's my question.
If I understand correctly, you want to understand from B2 if they have done any study regarding the safety and aspects of methanol involved on board a vessel. Is that correct?
So what I asked was, methanol using the methanol, is it safe for the ship or just for the human, the crew?
Okay. So, Kochi B2, would you like to clarify to D4 regarding
Yes,
their
sir.
query?
Yes, sir. We would like to say that it is safe for ships as well as environment as well as to humans. As if there is a less methanol spillage, then the emissions are very less, and so it is safe for humans as well as the ships, because the carbon emissions and ships are very useful for that, and the ships can be useful because it will give them higher efficiency to perform as compared to the normal fuels.
Thank you, Gochi B2. And if you have got some specific studies which have done this risk assessment and all, it will be good if you could share those.
Surely, sir.
Team A2, you have raised your hand. The floor is yours, please.
So I have the question that methanol has a low calorific value than the gasoline. So that is for sailing the same distance will require more methanol fuel oil as comparison to gasoline. So how you are going to solve this issue? That is, if any research you have done in this.
Okay. B2, would you like to respond?
Yes, sir. So as methanol is a renewable resource, okay, and the regular fuels are non-renewable resource. So we are using a renewable resource, so it's not gonna deplete with time as compared to the non-renewable resource. So that's how we can solve the problem. And we there are other steps taken by biomethanol is also there, and there are various other things to use that.
Okay, thank you.
Thank you.
Welcome, sir.
I see the hand of A2 up again. Is that a different question you have, A2? Please go ahead.
Yes, sir. Sir, I want to ask that in the presentation it was said that formaldehyde emissions are high. So, what will be the effect of formaldehyde on the nature and the health of the people?
B2, would you like to respond to that with respect to formaldehydes?
Yes, sir. Like formaldehyde emissions are that is not very harmful. Just they are the emissions as compared to the carbon dioxide emissions, which are causing various problems to our environment, and the formaldehyde emissions are very less as compared to that. Okay, emissions are higher, but the effect is very less as compared to CO2. So.
Thank you.
Okay, sir.
I see no further cards on the table. So with that, I would request Mumbai 1 C2 to kindly take the floor and introduce the paper. Mumbai 1 C2, the floor is yours.
Thank you, sir, for giving us the floor. I would like to present some presentation, sir.
Please go ahead.
Okay. Sir, is it visible?
Yes, please go ahead.
Okay. So, good morning to one and all, respected chairman, dignitaries, and all respected teams. This is Team C2 from Mumbai Zone 1, and I would like to present our ideas on the topic prevention of engine damage due to catalytic fines. So, our team leader is Cadet Shreyang Ganguly, and I, Cadet Ayush Kanuja, and my team members are Cadet Siddharth Kumar and Kavya Sununti. So, I would like to get started with the So these are properties, as you can see, density 4 point as been explained, that is the flow of liquid, and acid number. These are the properties of heavy fuel oil, and these are the contents to be discussing about in this presentation. So I would like to pass on to Cadet Shrangangle for further presentation.
So we have seen several examples of engine breakdown. Different from
I'm going to interrupt you, Mumbai Zone 1. I am not able to hear very clearly. I don't know if it's a common problem, but you may like to switch off your video if your bandwidth is low, or unless you're sharing it too much, and that's why we are not able to hear you.
Slide, okay.
Okay, please go ahead now.
So which slide able to see?
The voice is echoing. I think you got too many units plugged around the same point.
My God. So which
Yes, this is correct.
which slide is
Go
open
ahead.
on your screen?
The presentation is visible. Please go ahead.
Yes.
So there is network issue.
Team C2, I cannot hear any dialogue from your end. Is there some connectivity issue you're having?
So there is network issue. Therefore, the screen is not visible.
Your PowerPoint is visible on the screen. However, we cannot hear anything of what you're saying. It came in between and then it has again disappeared.
Sorry to interrupt, sir. Can you give us 2 minutes to sort out the issue?
What I will do is you sort out the issue so that you have a proper presentation available. Meanwhile, I'm going to request Kochi D4 to take the floor if they are ready.
Ready, sir.
So Kochi D4, please take
Yes, sir.
your.
Yes, sir.
Okay. And meanwhile, Mumbai C2, please sort out your connectivity issue and plan out how you're going to do it, or you want to give a try now. I see your presentation back again. Okay, D4, your presentation is on. Go ahead.
Yes, sir. Good morning, honorable chairpersons and delegates from member states and other dignitaries. I'm thankful to the chairpersons for providing the floor to give our proposals in IMO MSC. We are there the delegates from D4 Kochi. Our main motto is to use ammonia as fuels for the ships. Safety of ships and safety of environment with relating to the ships is our prime concern. It can be achieved by modifying the infrastructure and the engines or using alternate fuels. As we all know, shipping industry contributes around 95% of the global trades and it contributes around 2.5% of the world's total emissions. This is because of carbon-based fuels, accidents, and etc. Although we have strict and stringent rules, when a new alternate fuel is introduced in shipping industries, the rules and regulations are to be made more strict for the safety of ship and the environment. The IMO has put a pathway to 0% carbon emission before 2050. In order to achieve that, at the earliest, we are stepping into ammonia as fuels for the ships. But there are some disadvantages in using ammonia as fuels, like the cost and toxic effect on human health, but that has to be managed. There are 3 main challenges in using ammonia as fuels for the ships: their flammability, their productivity, and the corrosivity. Ammonia can be burned in IC engines, like using compression ignitions with pilot fuel spark or spark plug, since it has a higher auto ignition temperature, high heat of vaporization, and a narrow flammability range. Since ammonia is used as a fertilizer, its availability as a fuel is a question. The global production of ammonia in the year 2020 was 187 million tons. And finally, the corrosivity. It is a major concern for ammonia as fuels. Corrosion occurs when the liquid ammonia that contains impurities or contaminants is brought into contact with the mild steel. Then comes the synthesis of green ammonia. Using renewable energy like solar power or wind energy, the water can be taken using high-powered pumps, and it can be separated into hydrogen and oxygen. And the air can be separated into nitrogen and oxygen. and these are fed into Haber's process, and the hydrogen and nitrogen are reacted at under high temperature and pressure to produce ammonia. And scaling up of ammonia production can be achieved by revamping the existing conventional ammonia producing units into hybrid units, and by establishing new plants. And a productive possible solution would be to revamp the existing plants into hybrid plants by introducing the electrolyzer, gradually adding more. Then comes the cost criteria for ammonia fuels. The relative economics of the fuels can vary significantly depending on the assumptions that are used. This graph shows the cost estimates of various fuels that are used for reducing the carbon emissions. The cost of ammonia decreases from the year 2030 to 2050, but this isn't the exact values, but an approximate values. As the number of ammonia-powered ships increases in the supply for the ammonia fuel will also increase, therefore the cost of ammonia will also reduce. When using ammonia as a fuel, the existing production and storage terminals at ports worldwide give ammonia an edge, making ship-to-ship, shore-to-ship bunkering infrastructure easier to develop. And also, there is a radial shift toward the use of ammonia as a fuel would help in reducing the CO2 footprint and sulfur emission. The existing knowledge gap in the use of ammonia fuel vessels can be minimized by performing an in-depth assessment of ammonia as a fuel with reference to technical, economic feasibility as an environmental performance compared to other fuels, and also carry out feasible study pertaining to bunkering, safety routines, and etc. And also, future seafarers can produce a prototype engine that can run on ammonia efficiently. Moreover, there are some key concerns for using ammonia as a fuels, and they are the future cost of green ammonia, the safety, risk assessed, and the global availability and scalability. Already 120 ports are readily equipped with ammonia trading facilities worldwide, and additional production to meet 30% marine fuel demand in 2050. However, there are some environmental benefits too, and they are carbon-free, sulfur-free, and produced entirely by renewable electricity, water, and air. It burns in an IC engine and it is metabolized in the environment. And main thing is safeties. The safety measures on ammonia as a fuel is we have to make appropriate amendments in the existing IGC code, Chapter 7 and Chapter 16, and also we must make some implementations in IGF code as amended in SOLAS Chapter 11.1. And the safety of seafarers is for highest priority should be given. And the awareness of location of safety showers, proper training, and availability of tanker safety guide is must for all the seafarers on board ship. And comes the storage. It should be stored in a cool, well-ventilated location, and there is a need for large tanks. So we'll either use Type C or prismatic tanks. And next comes the bunkering. Proper mechanical shielding of all leakage points and availability of water should be for capturing the leaked gas must be necessary when using ammonia for bunkering. And comes the fuel blending. Fuel blending is nothing but mixing of two or more fuels to reduce the emissions to the acceptable limits. There are some ongoing researches for ammonia-powered engines. The Wärtsilä is trying to make an ammonia-powered 4-stroke engine and a MAN BMW 2-stroke green ammonia engines, and the industry pilot project are that ship FC to convert offshore vessels to run on ammonia-powered fuel cell. And the NYK examines the concept of using ammonia as a marine fuel. So, as a future seafarers, we recommend to use the compliant fuels and increase in production of compliant fuels. Effective transport of fuel and bunker stations to clean and purify the fuel before supplying it to the ships using heavy fuel oil. And also, we must encourage the research and development for innovative technologies. And also, as future seafarers, we request the following actions to be taken. We must take actions to enhance the production of alternate fuels by upgrading the infrastructure of their production and promote the production of alternate fuels through adequate funding, promote the infrastructural changes to be made in already existing ships, encourage the fuel suppliers to develop effective transport systems for transporting the alternate fuels from the site of production, establish more bunker stations, and give adequate funding so that we can conduct an in-depth study on the efficiency of alternate fuels of different generations. We must also encourage the development of innovative technologies, and finally, we must analyze the percentage of reduction in the level of emissions and other air pollutants in the emissions as well as the health of the environment. So we conclude that ammonia is a promising alternate fuel with 0% carbon emission. Thank you.
Thank you very much, Kochi D4, and bringing about your suggestion that we must get ammonia ready. As you see, ammonia as a fuel. Noted, however, we look forward, considering your advanced approach in ammonia, to get concrete proposals as what can be done in IGC and IGF code, which is not there today as far as ammonia is concerned, because there are ammonia vessels on board which fall under these categories, and if there are missing points, we look forward to hearing from you as to what are the missing points which require to be taken up. I open the floor for interventions. B2, the floor is yours.
Thank you, sir, for giving us the opportunity. Sir, I have a question for D4. Like
Go
they
ahead.
have said that ammonia as a fuel, but sir, as we check, ammonia is very highly toxic for human as well as the environment. Okay, and if there is any spillage or anything, so there will be a huge loss of diversity and everything. So how like their bunkering facilities and everything is there, so we support that. But sir, ammonia as a fuel we would not suggest because it is harmful for human, environment, our biodiversity and everything. So
Would you like to respond on these comments of A2, please?
Yes, sir. Yes, sir.
Please go
Sir,
ahead.
actually, we aren't having any proper safety procedures in IGF or IGF code regarding using ammonia as fuel, sir. We are having a proper material for as using ammonia as a cargo, but still we aren't having any proper things for using ammonia as a fuel, sir. So we need some safeties from. We need to proper follow safeties like as they are following it in land. Example, fertilizer companies and those things using ammonia in land. So we can also maintain same safeties as in land, sir.
Thank you. So if I understand you correctly, what you're saying is that we are dealing with ammonia anyway onshore, especially in the fertilizer industry, and if we can safely handle it here, as well as in transportation as a cargo, we can expand that to when we use it as a bunker. Okay, thank you for your clarification, D4. B2 has asked for the floor. B2, the floor is yours.
thank you, sir. So we would ask them that. So if ammonia, there will be something in the starting. Also, there will be some trial and error method. So there will be again problems with that only. Like if there are trial and error methods of ammonia carrying, or if there is any problem with that, the same thing will be affected to our environment. And if that is in a large quantity, that will cause drastic effect to our environment. So
I think if you're talking of trial and error, as secretariat, we can come back. It is not that ammonia is something new. Ammonia is, as correctly pointed out by D4, already raw material used, especially in fertilizer industry and all. So yes, trials on engines and all, and I'm sure engine manufacturers and all will be taking due care of that. However, if you have some specific concerns, we would look forward to hear from you if you are aware of any practices being followed which are giving that apprehension to you. I see no further hands on the floor. Oh, I see C2 is up. C2, would you like to take the floor?
Thank you, sir. I would like to ask before that, how can we get rid of corrosiveness to certain materials if we are using ammonia?
Would you like to respond, D4?
Yes, sir. Yes, sir. Sir, actually the same thing, like as I said before, so in land we are using the same pipelines, so we have to see the MSDS, material science data sheet, so that we can use some compliant pipelines and storage materials for this storage and all those things, so that the corrosiveness can be reduced.
That will be, yes, thank you for your clarification. Yes, we can request you also, if you are going ahead with certain trials and all, to share data, because data with respect to corrosiveness, with respect to safety aspects, all that, if it is shared, the other member states would get comfort. I see the hand of A2 up. A2, you can take the floor.
Sir, my question is, to use the new type of fuel, engine should be developed and it will take more time. So should we not enhance the present fuel which we are currently using?
A2, I think, yes, since we are in MSC, we are looking at the safety aspect. I'm sure MEPC is looking into the aspect, and one of the key concerns is environmental. So as Secretariat, I can assure you that all these aspects are being looked into, but the environmental concerns are really requiring to look at alternative fuels. If you want to add anything, D4, I will hand over to you.
Sir, could I ask him to explain ask the question again, sir?
What A2 wants to know is, why can't existing fuels continue? Why are we looking at other fuels, possibly, if I understand your question correctly,
So
A2.
actually, the IMO has set a target to reduce the carbon emission to 0% with the year 2050, sir. So when using HFO or any fuels containing carbon in it, we can't achieve it by using it, sir. So we need a fuel that doesn't have any carbon content in it. So that's why we are preferring ammonia as a fuel, sir.
Just one correction from the Secretariat. IMO has set targets, but that is 2050 is linked to a 2008 value reduction based on that. 2070 is net zero. So please be aware of the correct terminologies. There are two terminologies. One is net zero. So we are looking at net zero right now. There are discussions on whether that requires a review, but I would request all MSc participants also to be fully aware of the discussions at MEPC and other organs of the IMO, to be aware that the correct terminology as well as values are used when discussing in the forum. Thank you. Does that answer your question, A2?
Yes, sir. Thank you for the information, sir.
Yes, sir.
Now I see I did hear a very good connection from C2. So I assume C2, you are now ready to take up your paper?
Yes, sir.
Okay, I hand over the floor to you, C2, to introduce your paper.
So can I start?
Go ahead, please.
Good morning to one and all, respected dignitaries, chairman, and all respected teams. This is Team C2 from Mumbai Zone 1, and I would like to present our ideas on the topic prevention of engine damage due to catalytic fines. So, our group leader is Cadet Shreyang Gangle, and myself, Cadet Ayush Kanoja, with my team members, Cadet Siddharth Kumar and Cadet Kavya Solanki. So, next. Please move to the next slide.
If possible, please do a slideshow so that people can have better visibility.
So let's look upon the properties of the heavy fuel oil. These are some of the properties of the heavy fuel oil, and we will be looking on the contents. Next slide, please. So we will be covering some of the contents like background prior to bunker fuels, during and immediately after bunkering fuel delivery, and we'll be discussing and we will be elaborating about these contents. So I will move on this present to Cadet Shreyang Gangle for further representation.
Hello. So we have seen several examples of engine breakdown resulting from catalytic fines sludge have accumulated in the tank and entered the fuel system during operations. So therefore, the international legislation requires the use of fuel with a limited sulfur content has led to an steady increase in the level of catalytic fines found in fuels, which has been from 3.5% to now reduced to 0.5%. The current global average for low sulfur fuel is more than 30 ppm, and this level increase the danger of cat fines settling and accumulation in the bunker and settling tanks. The current, sorry, it appears that the majority of the fuel samples received and analyzed by DNV Petroleum Service in 2013 were tested against the older version ISO 8217 ratio 2005 marine fuel specification instead of the latest ISO 8217 ratio 2012 specification. Then and it also increased the risk that in rolling condition or rough weather, the fuel entering the purifiers contains cat fines in a concentration exceeding that which the purifier are able to handle. Taking the unscheduled and costly engine breakdown into consideration, we find it somewhat surprising that the majority of operators are still testing against the older ISO 8217 ratio 20051.
And this is, however, a discrepancy between the maximum acceptable level of CAT fines as stated in Common Marine Fuel Specification, such as ISO 8217, and those recommended by engine manufacturers, which are typically 10 to 15 ppm. And therefore, in this aspect, we have summarized the main recommendation. So first is prior to bunker fuels. We have to ensure that there are uh, many empty tanks for the newly purchased fuel. Secondly, the newly purchased fuel should be quality analyzed statics of the port of supply, and it should be relevant warning issued by the test laboratories. Third is ensure that the vessel have sufficient fuel on board to enable the testing of new bunkers prior to usage. The vessel should avoid using of newly purchased fuel without obtaining and acting on the fuel analyzed. We can see from the chart that use of heavy fuel has increased from December 2019 to October 2022, and it's going on. Third, and here we can see that which all the ships, all the bunker ships, chemical tankers are using the heavy fuel oils. And now we see that during and immediate after bunker fuel delivery. Ensure the representative bunker samples are drawn in line with industry guidelines and tested by a suitable independent laboratory, preferable against the ISO 8217 ratio 2012. Specification requirements are the drip fuel samples should be taken from each bunker source bar tankers during bunkering. Expedient dispatch to follow from bunker port to laboratories for analysis with the provision that the fuel analysis report return to the vessel as soon as possible in case prior to use the bunker fuel. Now I would like to hand over the next slide to Cadet Ayush Kanodia.
During use of bunker fuel, it is recommended that a proper fuel system check uh, is carried out by taking samples throughout the fuel system at intervals of 4 to maximum of 6 months. However, fuel system check samples should be also taken whenever aluminum silicon is bunkered. It is recommended that where the engine uses the heavy fuel oil, that should be range between 10 to 15 parts per million. Subsequently, the recommendation will carry out proper testing of samples taken before and after the purifier as well as before the engine at the same time. The samples should be sent to accredited laboratories for analysis. Purifiers. Wherever possible, run two purifiers in parallel with minimum flow and keep the HFO inlet temperature at optimal temperature of 98 degrees Celsius, because as heavy fuel has higher viscosity, so at 90 degrees Celsius, the viscosity will reduce. If the vessel is equipped with a convection purification plant, always ensure that the purifiers are fitted with the optimal gravity disk corresponding to the actual fuel and fuel test result. Purifier capacity should be sufficient to cope with daily fuel consumption plus 10% in order to enable some recirculation of fuel in the settling tank to occur. Regular checks of the purifier should be made by manufacturer service engineers to enhance system efficiency. Fuel system filters should be regularly inspected and learned not only when higher differential alarms are activated. However, where a ship has bunkered, dirty fuels are a few times tank cleaning at shorter interval should be considered. Fuel storage, settling, and service tank. This storage and handling is crucial part. So I would like to give some precautionary ideas. Uh, Avoid mixing by storing newly purchased fuel in empty tank. Ensure that the vessel has sufficient fuel on board to enable the testing of new bunkers prior to usage. This must be carried out by following the latest ISO standard of lowest permissible cat fines up to 60 ppm. Uh, Frequently draining of water and bottom settled sediments from fuel storage, settling, and service tanks should take place. Drain oil from automatic fuel oil backwash filter should not be reintroduced into the fuel treatment system. Cleaning, settling, and service tanks during dry docking in order to deal with any long-term buildup of cat fines and sediment in the bottom of the fuel oil storage tanks. If fuel oil is stored for a long period, cat fines will settle at the bottom of the tank in rough weather these particles will be stirred off, and hence it is abrasive. It can damage the container of the storage tanks of the ship. Now I will like to pass on this to the Cadet Kavya Solanki for further representation.
Board. If we talk about fuel treatment heaters, they should be opened and cleaned regularly to ensure that the optimal temperature of 98 degrees Celsius for purification is reached. And also, if we talk about purifiers, they should be opened for cleaning at the scheduled interval as recommended by the manufacturers or is suspected. But to perform this task, one needs spare parts. So vessel should maintain necessary spare parts on board. If we talk about training, the vessel should be provided with proper management plans and bunker handling from the company. Also, the personnel responsible should be sufficiently trained to be able to fully and independently perform and operate and maintain all the maintenance equipment, and that should be ensured by the operator. Also, the personnel should have existing qualification prior to employment and also through the ongoing training, and should also have market updates wherever needed. And at last, the personnel responsible should be familiar with the raised issues in these recommendations.
In C2, we seem to have lost you somewhere in between. Are you finished with your presentation?
So our team member is having some network issue.
So can you conclude now? Because as such, I think time-wise you are more or less.
Sorry to interrupt, sir. I would like to tell us about the problem if the problem is found. So if a problem is found, so the first thing to be done is cleaning of all relevant fuel tanks, including system and components. And also, if a component of an engine is damaged, it should be replaced or its machining should be done. And if off-spec fuel is the issue, then the removal of contaminated fuel from the vessel should be done properly with proper safety.
And here I like to continue. Action required. Operators are recommended to carry out an interval review of their bunkers, handling, and treatment procedures. They may also wish to enhance their planned maintenance by increasing inspections of engine cylinder assembly part in order to provide early identification of fuel-related problems. Apart from inadequate equipment in the actual operation, or rather the improper operation, that may be the main reason for insufficient reduction of in-cat fines. Improper operation in turn may be due to the lack of an understanding and the attitude towards the proper onboard fuel treatment. And here I would like to thank you for giving us this big opportunity to present our technical paper. Thank you.
Thank you, Mumbai 1 C2, and I will reserve my comments for later on. Along with the closing summary, I will right now open the floor for interventions. I see no cards on the floor, so I assume none of the other member states have got any queries on this paper. I'll give it a minute more in case thoughts are being collected, and then I will summarize the session. Okay, D4 Kochi, you just beat me to the mic. Okay, D4 Kochi, the floor is yours.
Thank you for giving me the opportunity, sir. This is Flavius from D4, and they proposed regarding the machining and maintenance of machinery. But how do we rectify the problems based on catalytic fins?
You want to know, like in case problem occurs because of catalytic fines, what was the steps to be taken? Do you have a response to that, Mumbai 1C2?
Yes, sir. Also, we can reduce from 60 ppm to 50 ppm, and rather than we have the major like taking the temperature of heavy fuel oil to 98 degrees Celsius, then we can reduce the cat fines. This will help us a lot. These are the prevention measures I've gone through.
Okay, does that answer your query, D4? I see no further cards on the table, so I will now attempt to summarize the session. Taking the last paper first, that is Mumbai 1C2. Thank you for bringing the issue of cat fines and the difference between the two standards of ISO 2005 and 2012 back to the table, and highlighting that some suppliers are still testing as per the older standard. If there is a concrete proposal on how this can be addressed, do let us know and we can take that further up. Otherwise, thank you for bringing out your research on the various procedures, which all we can say is member states can advise their companies. If in the existing SMS systems it is not already addressed, which should be there already, they can relook at that possibly if there is a feeling that this still requires to be looked at in the existing SMS system, because all these aspects should be covered in the shipboard management system of bunkering and bunkering procedures. So we would request member states to see that. Mumbai 2A2 brought in the aspect of cold flow associated with the very low sulfur fuel oil, relevant point, and how to address it by use of additives and their suggestions of pre-flow. In the event, you have more research and suggestions on how to address this in the training modules and all. We would look forward to concrete proposals from your end, as well as sharing of information on this. Kochi B2 brought in about methanol and the issue of formaldehydes. We look forward to further details from you for sharing with other member states with your experience with methanol as a fuel. Similarly, Kochi D4 brought in ammonia and the need to address some issues in IGC and IGF code. We look forward to concrete proposals from you on this as to what requires to be done and what is missing there to address the safety aspect which MSC is concerned with. So thank you for your active participation in this session. We will now take a short break, reassemble at around 11:55 to start the next session at 12 noon. In case the judges have any comments, I'll just wait in case they wish to say anything. Otherwise, over to Gaurav, please. Gaurav, please take over.
Okay. I was just waiting for judges. Anything from judges, sir? Sarma Murthy, sir? Dr. Saxena?
No, negative. Negative.
Negative from my side. Negative.
Right, sir. Then we will reconvene at 11:55 and start at 1200 hours for the third and final session of the day. So 1155 hours. Thank you. 57. Mr. Ramamurthy, sir?
For a change, he is late.
For a change, I think Mr. Datta is there. Mr.
Yeah, I'm
Datta?
there. I'm there.
Okay, thank you, Mr. Mehrotra. Mr. Mehrotra, sir? I am unable to contact Mr. Ramamurthy. Mr. Mehrotra is joining. I will try Mr. Ramamurthy again.
I left. Okay.
Ah, yes. There he is. Okay. So, welcome back, ladies and gentlemen, to session 3 of MSC today. There were 4 teams comprising Group 3, but due to various circumstances, including medical reasons, Team D2 from Mumbai 1 had to drop out. So we have balanced 3 teams, which is Team A3 of Mumbai 2 zone and teams B2 and C1 from Chennai zone. We must appreciate that these teams indicated their readiness to advance their session at such short notice. Thank you, teams. The Chennai zone guide is Mr. Mahesh Subramaniam. You would recall that he was guide for the MEPC session also. So he's doing double duty. We appreciate that. An alumnus of DMT Kolkata, Mr. Mahesh Subramaniam, sailed for 12 years before coming ashore in 2007. He was instrumental in setting up the Anglo-Eastern Maritime Academy, and he was there from 2010 to 2019. He is presently involved with environmental and sustainability related work in the full Anglo-Eastern group. He is active in IMEI activities and regular MEPC meetings. Mahesh is also contributing on various aspects related to ballast water. The Mumbai 1 zone guide is Mr. Sunil Kumar, who has already been introduced, and the Mumbai 2 zone guide is Mr. Ritesh Kaushik, who has already been introduced. I now hand over to Mr. Rajiv Nayyar, the chairman, for taking the session forward. Over to you, Rajiv.
Thank you very much, Gaurav, and welcome back to everybody. Welcome back, delegates. We commence session 3, the last session of this year's mock session, both under MEPC and combined groups. So look forward to your active participation in this. And I now invite Mumbai 2A3 to take the floor and introduce the paper.
Yes, sir. So, first of all, good afternoon, sir. And my name is Shubham Kumar Jha from Team A3, Mumbai 2 Zone. And thank you for giving this opportunity so that we can give our views. So, fast forward, we are moving to the topic development of further measures to enhance the safety of ship relating to the use of fuel oil. So, why we need to enhance the safety? So, this answer of this question we can give on 1st January, new limit on sulfur content in fuel oil used on board ship came into force, and making significant milestone to improve air quality, preserve the environment, and protect health on board. So due to this, vast majority of ships started using low sulfur content, and safety issues have not been reported to IMO after this initiative. And we can see 5 beneficial changes of IMO sulfur limit for ships fuel oil came in 2020. So that we can think as an achievement for us. And information for the adaptation of alternate marine fuel is that how we can adopt a sustainable fuel, means on what basis we can choose a sustainable fuel. So giving the guidelines given by the International Maritime Organization that sulfur emission should be less, and parameters like chemical structure, fuel material, energy comparison, physical state, flashpoint, maintenance issues, energy security impact, so that best fuel can be selected for the further research and development. So we have also used these parameters in our research paper, and seeing all the criteria, we suggest we want to propose that ammonia can be better option as marine fuel as compared to HFO or currently available option of marine fuel for the sustainable development of environment and also for the safety of human life. So moving forward, by this chart, I want to show that how we can say that ammonia is good and better than other fuel. So we can see here in this chart, fuel type storage condition. So minus 34 degrees Celsius or 10 bar. I think it is, we can make arrangements that is simple. 34 degrees Celsius can be provided for any fuel. But in hydrogen case, we can see minus 25 to 253 degrees Celsius is something very difficult to create on ship. If the ship goes to polar region, there is a minus like 100 degree or 70 degree, 80 degrees Celsius already there, and we need to give minus 250 degrees Celsius more. So it will create means like seize of engine may be seized. So that is not good for the ship. It may stop there. Relative fuel tank size, we can see it needed 4.1 and hydrogen 7.6. Relative capital expenditure is very less. That's the main point, 1.2 only. And the fuel cost and availability is there expensive but relatively low price for carbon natural fuel. But expensive in the sense it depends upon the countries. Like China is the highest exporter of ammonia, so for him it is cheaper, and for India it is somewhat costly because India is not producing that much of ammonia still. And moving forward, we have production of ammonia fuel. So how we can produce the ammonia? So production of ammonia from natural gas is conducted by reacting methane with steam and air coupled with a subsequent removal of water and CO2. So by this flow chart, we want to describe how we can produce ammonia. So natural gas is being taken and desulfurized. Steam has been provided. Next step, reformer, and main this water gas shift reactor and steam reformer. The main work of these two in further steps so that we can easily extract the CO2 separator. The current CO2 can be easily extracted from this, and then we give methanation. ammonia synthesis and ammonia separation is being taken together with unreacted gases, and then it is like ammonia is being produced at last. And our next step is to benefits of ammonia as a marine fuel, means how ammonia is beneficial for the as a sustainable fuel and also on the human life and safety. So zero carbon emission, as there is no carbon atom in the ammonia molecule, it does not emit CO2 during combustion. So it's a very important point, zero carbon emission. So safety of life also matters here. Energy density, ammonia has an energy density similar to methanol and more favorable than hydrogen. Additionally, it requires less cooling than cryogenic liquid hydrogen. And next, lower cost synthesis of ammonia from zero carbon hydrogen using the Haber-Bosch process. Now Haber-Bosch process is being used so that it is very cheap. So this process doesn't require a lot of money. Haber-Bosch process requires less energy than synthesis of methanol or methane, meaning the ammonia will always be cheaper than either of these zero emission fuel options. Scalability is nothing. Scalability we just give like long term potential decreasing. Am I audible, sir?
Continue going on. If there's some problem, we'll come back to you.
Yes, sir. Scalability, ammonia has longer term potential. Decreasing cost of renewable energy will support the scalability of ammonia as marine fuel. We have more points on this. Ammonia can also hold it on as fuel. In this case, storage of ammonia and transportation of ammonia also is easy, because we have been doing transportation of ammonia. We are having 200 gas tankers in which 40 are always active to carry ammonia from one country to another country. So we have the experience of storing and transportation, so there is no matter of how we can carry and transport the ammonia. Ammonia has an auto ignition temperatures of 651 degrees Celsius, and the risk of ammonia fire is lower compared to the other fuels. So some people see like auto ignition, high auto ignition temperature as a problem. So for resolving that problem, I think we can we can mix any other fuel in there so that we can lower the ignition temperature if you want to start the engine at a low temperature. But it has it has its own auto ignition temperature. It will ignite himself if it is more than 651 degrees Celsius. And next, ammonia has a higher energy density, and even liquid hydrogen at 8.5 megajoules per liquid hydrogen has to be stored at cryogenic condition. So that is the point again repeated here. What we shown in chart, minus 253 degrees Celsius is not much easy to provide for a fuel, and for in case of like ammonia, minus 33 degrees Celsius is easy. General design of ammonia fueled ships. So as we discussed that ammonia can be used as a fuel on ship. So what are the reforms that has to be done on the ship for the ship to be used run on marine ammonia fuel? So this is the this is the design, or you can say like blueprint which we have created. Like this tank is full storage hold space, and in this full storage hold space there is a oval shape you can say NH3 fuel tank. So this thing gives the double protection. This thing gives the double protection to the ammonia fuel tank, because it is very reactive to the heat. It doesn't if there is any substance like flammable substance nearby this, it will react with that and ignite himself. So there is a double storage hold space, and there are several valves, like there is bunker station valves so that bunkering can be done, and there are two valves, pressure relief valve and tank connection spaces and vent mast. And then it is connected with fuel preparation room. In this fuel preparation room we can also lower the ignition temperature of ammonia, and then it goes to gas safe machinery spaces and engine. And now steps to overcome the challenges to use ammonia as a marine fuel. So as our topic is to safety of life on board ship, and sustainable development of environment also matters. So we focuses on we are focusing more on the safety of life. So focuses area reduces the risk of ammonia leakage during bunkering and limit risk and consequences of exposure to ammonia for personnel involved in the bunkering operations. So what he has to keep in his mind, like Leakage detection with automatic closing of bunker valve can be used. So this is also a very important mechanics which we can use. Leakage detection with automatic closing of bunker valve if there is any emergency. In case water spray system, bunkering manifold to reduce toxic vapors in the bunking stations. Moving forward, we are having second, protect ammonia storage tank from excessive heat input. So ammonia doesn't react himself. It need any exposure in air and any like flammable kick to it. If it gets, it will ignite himself. So flammability of ammonia in open air is significantly lower than for methane. Therefore, relevance of adopting the IGF code requirement for S60 shielding boundaries of superstructures facing fuel tanks on open deck, which is required for the methane fuel tanks, should be considered. So here we are also having concern of like life of the seafarers on board. So for them, we can use like adopting the IGF code requirement S60 shielding boundaries. And second, on the other hand, we consider all IGF code requirements aiming to protect a storage tank from heat input as relevant also for tanks in order to protect ammonia tank from excessive heat input in case of fire. They should be segregated from spaces with a high fire risk like, for example, machinery spaces and category A be protected by water spray systems of cooling if cooled on open deck. Protect ammonia fuel installation from external events and could damage the tank, causing accidental release of ammonia. So we have to, like external things should be kept, at a higher distance from this fuel. And the collision and grounding in case of requirement defined as IGF code of LNG tank and piping are considered relevant. Ammonia tank should preferably be located away from the exposure to ship and cargo operations. Alternatively, appropriate mechanical protection should be considered. Reduce the risk of leakage in machinery. Reduce the risk of leakage in machinery spaces, which could expose personnel to toxic vapor and make machinery spaces inaccessible. So, for the spaces in ship, ammonia fuel system should be arranged with secondary boundary, which we shown in previous, our blueprint of how we can make the spaces and the tank system in the if we are using the ammonia fuel. So we should have the secondary boundaries to prevent the gas leak from the spreading to the engine room. Next, special care should be taken to ensure, if it is possible, safely isolate equipment machinery from the fuel system to maintenance purpose. Manual valves and fuel lining. So I think manual valves should not be suggested. I think we should use automatic valves, which will reduce the like any hazardous situation. Now,
You will have to start looking at your conclusion because
yes,
we will be stopping you shortly.
Yes, sir. Yes, sir. So the limit explosion risk by elimination of ignition source in areas where it is likely that release may result in flammable vapor concentration. Same case, sir. We have to look after how much heat is there in ammonia and how it can react with other liquids which are available in the surroundings. So now coming to our conclusion is like, we were very strict to the topic safety of life and using a sustainable fuel for the environment. So we suggest that ammonia can be the future marine fuel for as concern of safety of life and sustainable environment development. Thank you, sir.
Thank you, Mumbai 2A3. I now open the floor for interventions. You can kindly unshare your presentation. Thank you. B2 Chennai, the floor is yours.
Thank you, sir, giving me an opportunity. I would like to ask ki as the person said ki the ignition temperature or the auto ignition temperature is very high for the ammonia. I would like to ask ki when ammonia is injected into the engine, it will have some issues in ignition since it has approximately 200 degrees Celsius higher than the other fuels used. So, what is the solution to that part?
Thank you, B2. A3, would you like to respond?
Yes, sir. This problem, we have also looked for it, and this problem can be uh, uh, hello, am I audible?
Yes, you are audible. Please go ahead.
Hello. The auto ignition temperature of ammonia is about 200 degrees Celsius. It is greater than gasoline and diesel. Therefore, it can be done by mixing some other basic fuel oils like gasoline and diesel in it, which reduces the auto ignition temperature to a very lower level. And this is how we can get the auto ignition temperature.
Okay, thank you for the clarification. A3C1, your hand is up. You may take the floor.
Thank you, sir. Uh, Thank you for your consideration. We appreciate the efforts by the delegates of the team for such an informative presentation. We encourage the implementation of ammonia as a fuel, as an alternative fuel. We have a recommendation. Uh, we want to recommend A3 that you can consider in the designing of your in their designing mechanism the chemical reaction rate of the ammonia fuel, which has higher ignition temperature than the traditional fuels and low flame velocity. And also, I would like to ask, how can you resolve the problem of ammonia discharging through exhaust because of its low combustion temperature? Thank you, sir.
Sir, thank you, sir. Thank you. We also we were also looking after this. So we find out that we can use such type of automatic filters, which can, like when engine is moving and the exhaust is getting out of the pipe with the help of suction. So we'll use such mechanics that it will suck the whatever is burning and get out of through it automatically. Like if it will sense with the help of sensor, it will sense that the temperature is getting high and acids are getting more and more, and it should be get out of this. So it will just suck out of that and throw it out of that system.
Thank you. If you could share what research you have done on that, it would be helpful for other member states.
So still we are doing, sir, and it is just like half on the stage. Sensor we are working for that. Which sensor to be uses? Like there is MQ3 sensors and all. So we are working on the coding also.
Right. So you can share that in further sessions.
Yes, sir.
I see no further queries, so I will now invite Chennai B2 to take the floor and introduce the paper. Chennai B2, the floor is yours.
Thank you, sir, for giving me the opportunity. Good afternoon, respected chairperson, co-chairperson, and all the delegates. I am Ashutosh Srivastava from Team B2 Chennai Zone. Today, me and my teammates are here to present a paper providing information on preventing the slag formation, wax formation, leakage, and the sticky nature of the blended fuels. Now, I would like to call upon my teammate Harshit Tiwari for giving a brief introduction on different marine fuels that are used.
Good afternoon, everyone. I would like to reflect some information on different marine fuel oils that are used nowadays and their manufacturing process. As we know that the fuels are needed for propulsion and power generation and of the generation of electrical supply on board ships. And fuels may be used directly in the prime mover like a diesel engine or used in a boiler for generation of steam, which in turn is used for propulsion turbines. Petroleum gas turbines are used in naval ships. The fuels most widely used are light diesel oil, heavy fuel oil, and high-speed diesel oil. The light diesel oil was the oil used earlier in both low and medium speed diesel engine for propulsion and medium speed diesel engine for electrical power generation. Later, after the Gulf War, due to the steep rise in the light diesel oil cost, slow speed diesel engines were developed to burn heavy fuel oil directly. Earlier, the engines were using heavy fuel oil with viscosities up to 380 centistokes at 500 degrees Celsius, but at the present day, engines are capable of burning fuel oils of viscosities up to 700 centistokes at 500 degrees Celsius only. Initially, medium speed engines for the power generation were also developed for burning blended fuels, where a percentage of diesel oil was mixed with heavy fuel oil. The latest generation of medium speed diesel engines are designed for burning same heavy fuel oil, which are used in propulsion medium speed engines and bringing the concept of unit fuel oil. Almost all petroleum fuels are obtained by fractionating column and crude oils, and there is a wide variety of fuel oils which are choice may be made. The fuel oils of higher viscosities are cheaper in cost, but they are also having a higher level of impurities which are harmful in diesel engine operation and their component life. The fuel quantity has a major influence on installation and the cost to the necessity to have purifying equipment, maintenance due to higher wear and other effects on the engine components caused by impurities. We know that during the production of marine fuel oil, a number of chemical reactions are taking place. And to make these chemical reactions more feasible, or we can say that to increase the rate of the chemical reactions, we use the substances known as catalyst. So we can also say that catalyst is one of the most prominent and a very benefactor component in the large scale production of the marine fuel oil. As we look in the diagram shown in the PPT, it shows us a fractionating column in which we can see that when crude oil is heated at different temperatures, we get marine fuel oil along with a number of byproducts such as diesel, kerosene, petrol, etc. According to ISO 8217, there is a requirement of maximum limit of 60 ppm of catalyst powder in the fuel oil while entering the engines, and there is a limit on the quantity of the silicon and aluminium that both of the components should not be more than 15 ppm while entering the fuel engines. But the mainstream engine manufacturers nowadays suggest us that the content of the catalyst powder should not be more than 10 ppm at the inlet of the engine. But it is generally has been come to notice that the average quantity present in the marine fuel oil is usually more than 30 ppm, which is undoubtedly increases the chances of failure of the engines at very early stage. The catalysts which are used for the production of the marine fuel oil are though one of the biggest contributors in the production of the marine fuel oil, but they also contain amorphous aluminum silicate or zeolite molecular sieve microsphere, which contain aluminum oxide, silicon dioxide, and other harmful chemicals. When the particles of the catalyst when gain the hardness and become denser, they can cause blocking of the pipes, blocking of the nozzles, and they can also have a severe damage on the engines of the marine vessels. Also, as per the new rule of IMO, the sulfur quantity is capped up to only 0.5% mass by mass on the seagoing vessels. Although ships containing exhaust filters are excluded from this category till now. There is no prohibition on transporting high sulfur marine fuel, but it can't be used in the fuel tank until and unless it has an exhaust filter. Now, I would like to call my teammate, my friend, Mr. Shobit Kumar, to reflect on concern related to this information. Thank you.
Good afternoon, everyone. I am Shobit Kumar, hereby to raise some concern associated with the information given by Harshit. So when these new blended fuels are stored for a long period of time, this sludge formation takes place as a result of the precipitation of asphaltene out of solution. This sludge have a capability to block the filters, nozzles, pipes, fittings. Thus, it can harm the engine of marine vessels. Also, there is an issue that once asphaltene precipitate out of the fuel, there is no way that we can mix back to the fuel components. In low temperature conditions, major operational problems may arise because due to the higher paraffinic nature and potential for wax formation at lower temperatures. New blended products with a high distillate percentage could be susceptible to this. These new blended fuels have a very low viscosity and they are stickier as compared to earlier ones. The low viscosity results in leakage in between engine's plunger and barrel for the fuel pump. Moreover, when internal fuel injection system leaks it, it could cause the engine's fuel pressure to drop, which could have an impact on the engine's performance. Now I would like to hand over the floor to my teammate Ashutosh to give some proposals on these concerns.
As stated by my teammate Sobit, we came across many concerns regarding the use of blended fuel oils. So I would like to put some proposals regarding to these concerns. Since we are in the category of developed nations with a large interest in shipbuilding and research and development, so we can develop some sort of fuel mixing system in the fuel tank so that it keeps disturbing the blended fuel continuously and slowly, so that the asphaltene doesn't precipitate out. Also, we can make some changes in fuel filters so that if there is a little bit precipitation of asphaltene takes place, then it can be filtered out before reaching the nozzles, fittings, and engine. To ensure that newly blended fuel neither form wax in low temperature nor it creates any other problem at high temperature, we can work upon proper insulation arrangements with some temperature control. While making these arrangements, we must take care of the flash point of the blended fuel so that the risk of fire accidents can be avoided. To ensure that there is no pressure drop between the engine's plunger and the barrel for the fuel pump, we can upgrade and change the nozzles, fittings, and gaskets according to the new viscosity of the fuel. And for tackling the sticky nature of the fuel, we can work with the engine oil manufacturers and upgrade the engine oil according to the blended fuel requirements. Thank you, sir. This is all.
Thank you very much, Chennai B2. Before I open the floor, I just wanted a clarification on the term of exhaust filter. What exactly are you trying to talk about? Are you talking about the scrubber mechanism to control the SOx emission?
Yes, sir. I am talking about the scrubber mechanism only.
Request you to kindly use terminology consistent with IMO terminology use so as to avoid any confusion. I now open the floor for other member states to have their comments. Okay, I have Chennai C1. Chennai C1, you can take the floor.
Thank you, sir. Thank you, Chairperson, sir, for consideration. We appreciate the presentation put forward by the delegates of B2. We like the idea mentioned about the asphaltene precipitation can be avoided by using mixing system in the fuel oil tank that continuously keeps disturbing the blended fuel. We would like to add on this to consider an enhanced temperature control unit within the mixing system in order to avoid rise in the vapor pressure inside the tanks, which can lead to disasters in the ship. And I would also like to know about any intrinsic or extrinsic safety mechanism for this in order to avoid fire hazards within the tanks.
What you're saying is the proposed mechanism they want to put in the tank, you want to know how it will impact safety. Is that what you...
Yes, sir. Yes, about the mixing system. Yes, sir. I would like to know about that.
Thank you, C1. B2, would you like to respond?
Yes, sir. Actually, as he said, we are installing that temperature control system into the mixing system itself. But as we proposed, system is it is and we are also keeping the flashpoint into consideration so that hazards.
I am sorry, B2, you may have to repeat. At least I missed out half of it. I am not very sure about others. B2, could you kindly repeat yourself?
Am I audible, sir?
Yes, now you are.
Actually, sir, I wanted to put that point key as the delegate said, we are not putting the temperature control system with the mixing system. We are putting the temperature control system outside the tank with that insulation systems, so that the tank is separated from that hazardous effect of that temperature control system. Along with that, we are also taking care of that flashpoint of the fuel, so that that hazards of fire can be prevented.
I think, if I understood correctly, the question was regarding your proposed installation inside the tank. So there, what
Uh,
safety aspects have you considered?
Sir, exactly our proposals, the temperature control system was outside the tank along with the insulation.
Okay. Okay. Does it answer your question, C1?
Yes, sir. Partially, sir.
Okay. It would be beneficial if you could share more details of what systems you have proposed in the new technologies for blended fuels. Though I do have some generic comments, I'll take that in my closing remarks. A3, your hand is up. A3, you have the floor.
Thank you, sir, for giving us the floor to ask the questions. And B2 delegates, I agree with your views, but I want to ask that how will you remove the problem of sludge formation when the fuel oil goes below pour point, as it will create many problems on board a ship? So, can you clear that?
Thank you, A3. Would you like to respond, B2?
So, I would like to hear the question again.
His specific query was regarding sludge formation, which you have highlighted. Is there any proposal which you have which takes care of sludge formation?
So, regarding to the sludge formation, the upgraded filters that I proposed, the filters can be upgraded so that the sludge formated, if sludge formation takes place, it can be separated out in the initial level itself before reaching the nozzles and gaskets, etc.
Thank you, B2, and appreciate your efforts at these new innovations. Maybe you may like to take this up in an appropriate forum like SDE and all, being technical matters on design improvements and all which can take place. And safety related aspects we can take here in MSC. If there, I see no further cards on the floor, so I am going to now request Chennai. I see the hand of a A2. A2 is not part of this forum. Unless you have got your labeling wrong, in which case you may. Okay, thank you for lowering your hand. Chennai C1, you may kindly take the floor.
Thank you, sir. So we'd like to present our
Please
PPT.
go ahead.
Yes, thank you. Is it visible, sir? Shall we continue?
Yes, please.
Thank you, sir. Good morning, respected Chairperson, sir, honorable dignitaries, and the delegates of various member states. We are the delegates of Chennai C1. We would like to thank the Chairperson, sir, and the committee for giving us this opportunity to raise a motion for development of further measures to enhance the safety of ships relating to the fuel oil required by the MSC committee. The IMO slogan sums up its objective: safe, secure, and efficient shipping on clean oceans. In order to progress, the work intersessional agreed to establish contracting governments to inform the organization for transition to parties and member states of the organization of confirmed cases where oil fuel suppliers had delivered the fuel that jeopardized the safety of ships or personnel or adversely affect the performance of the machineries. Bunker companies has to fulfill all the requirements put under by state regulatory body. Companies performing bunkering are compulsory to have a bunker license for the regulatory bodies under the state jurisdiction. Surveys to be done before issuing bunkering license. The development of mandatory requirements regarding the reporting of confirmed cases where oil fuel supplies have failed to meet the requirements of the organization, taking into account that feedback should also be provided to the suppliers. The member states were encouraged to form a regulatory body to look into the bunker licensing scheme and surveys. The member state who wishes to implement bunker licensing schemes may modify and use templates as per their national law. States, States can also consider specifying additional requirements for suppliers working under the jurisdiction. The development of mandatory requirements to ensure solar's contracting governments take action as appropriate against oil fuel suppliers in confirmed cases of deliveries of oil fuel that does not comply with the specific requirements. With the deadline of IMO Sulfur Cap 2020 drawing closer, understanding the owner's concern to remain operational while complying with the environmental regulation, having a good implementation, fuel oil changeover plan is just the beginning of the transition phase. A very important aspect of the plan is to address the potential risk that may arise. Mandatory requirements regarding the documentations of the actual fuel batch when bunkering, providing a statement that the fuel oil delivered complies with regulations. The development of guidelines for ships to address situations where they have indicated results suggesting that the oil fuel supplied may not comply with regulation. Some concerns as a violation of SOLAS were a legal issue and should be confirmed by a port state, especially bearing in mind the consequences for the ships and crews. Using the draft regulation and action against suppliers in confirmed cases of deliveries of non-compliant oil fuels as set out in considering that in confirmed cases of supplies of oil fuel not compliant with the requirements, the party under whose jurisdiction the bunker were supplied should be required to report to the organization the action that they have undertaken in this instance. A bunkering licensing scheme would be the only possible way to address quality and other safety relevant oil fuel properties. A bunkering license scheme would not replace requirements for action against oil fuel suppliers in confirmed cases of delivery of non-compliant fuels. After a depth of study exploration through all the feedbacks and resources, our teams have put forth on a few proposal structures mentioned as follows. Generally recognize the usefulness of a voluntary licensing scheme for bunker suppliers to help ensure the quality and compliance of the fuel oil. The committee encourages member states to implement licensing scheme for bunkering suppliers any identified issues to its source in the supply chain on a national level. A certificate or grading can be provided to the fuel available within the bunker company in order to ensure fuel oil parameters under IMO regulation pre-bunkering. It is suggested that the Secretariat should consider engaging with the various member states in order to promulgate existing IMO regulations and various guidelines related to the supply and use of oil fuel and for collating information on issues faced by ships in using marine fuel oil. It is suggested that license with the Technical Cooperation Committee could be considered for this proposal. The committee is invited to note the discussion in the above paragraphs, consider the proposal as set out, and take action as appropriate. Thank you.
Thank you very much, Chennai C1. And before I open the floor for discussion, I think that is what we are here for, to hear your proposals. The committee is formed of all the member states, and the member states make the decisions for themselves. The committee is, the secretariat is a facilitator for that. So if you want to, if in your member state you have implemented, it would be great, very nice if you could share what you have implemented so that other member states can take advantage of that. And when you propose certain guidelines, those is what will be taken forward. I open the floor for interventions, please. Yes, B2.
Thank you, sir, for giving me this opportunity. I would like to add upon a point, as the delegate said, that checking of fuel and giving it grades according to it when it is supplied. But even after the fuel comes and is stored at a place, the quality of fuel can be altered. So I would like suggest that instead of doing only one check at time of arrival of the fuel, we can do multiple checks in between the stages. And then the grade can vary of that particular company or organization.
I am sorry, is this a suggestion of yours, or that multiple checks on bunker supply are done? Is that
So
is
it's
what
a
your
suggestion.
suggestion? Okay. So if you have a concrete proposal as to at what all stages you could do these checks, uh, apparently once a vessel sets sail, it has no access to laboratories until its next port of call. And onboard tests have their limitations in terms of what all values they can do. So if you could work out on what your exact suggestion is and put it forward at the next session, it would be good. Meanwhile, I see the card of A3 up. A3, you have the floor.
Thank you, sir, for giving me the platform to ask questions. I would like to question that sometimes water is added or gets mixed during bunkering with the fuel oil and leads to the energy loss during combustion and use. How will they eradicate this problem?
Could you repeat your question, please?
Hello, am I audible?
Yeah, please.
During the bunkering process, sometimes water get mixed due to some accident or leak. Then how will you eradicate this problem of mixing water, as it leads to the energy loss during use?
Uh, I think this specific technical question, maybe B3 would like, C1 would like to respond to it, but it's a technical process of how to, depending on the type of fuel, how you deal with contamination with water, depending on the type of water, fresh water or seawater. You have purification systems on board, you have other systems of dealing with it. Again, there are a lot of things, but in case C1 wants to add anything, but I think it's purely a technical query on a particular incident which you could possibly take over in the lunch break, unless C1 wants to add anything on this. C1?
Thank you, sir. So actually, all the points are covered in your speech, sir. There are no points to be added about the purification.
Thank you, C1. You could get technical info on this during a lunch break, I suppose, A3. I see no further cards on the
Okay, sir.
table.
Thank you, sir. That was great.
So I'll try to summarize now this session, which is the last session. We had Mumbai to A3 specifically talk about ammonia as a fuel they were looking at for future. We would like them to share further as the research goes on, concrete proposals as what could be done with respect to MSC aspects of what all should be considered from safety aspects of the seafarers, as well as any other related incidents which could lead to harm to any areas covered under MSC. Chennai B2 brought in about the issues of blended fuels, did talk of a fuel mixing system, did talk of catalyst and their issue with the ppm which is being found, but further we did not get any concrete proposal on how to deal with the issue of the observed value of catalyst being different from what is supposed to be covered under the ISO guidelines. They did talk of doing some research work on various mechanisms to deal with blended fuels inside the dealing with the tanks as well as with the filtering aspect. We look forward to your further submissions with details on this and that how that could be applied in relation to safety aspects. We did have Chennai C1 talk about the licensing scheme necessity, which already are guidelines given by this committee, and bunker suppliers are licensed. BDN is a document which is used to control the quality and declaration of the bunker suppliers. If they're talking of various action against fuel suppliers who fail to comply. So if they have implemented such a mechanism in their member state, it will be highly beneficial if they give the proposal as though this could be implemented universally and lead to more uniform bunker supply, which is complying with the standards set out for marine bunkers. So with that, I close this session. Thank you, delegates, for your participation, and I hand you over to Gaurav for his closing remarks. Thank you very much. Gaurav, you're muted.
Thank you, sir.
Would the judges be having any comments, sir? Any remarks, comments, observations?
No, that only comment is you are muted. That was the only comment.
Okay,
the
sir.
only comment was you are muted.
Yes, sir. So that has been taken care of. Dr. Saxena, sir? Anything?
Nothing from my side at the moment. No, thank you. Thank you.
Mr. Mehrotra? Mr. Mehrotra, any comments, sir? Any observations at this time? Mr. Datta? No. Okay, guides, anything to say? Guides, coordinators? Okay, then, so ladies and gentlemen, we had 11 papers on MSC. Yesterday we had 18 papers on MEPC. My thanks to the participants, the delegates who put up such a tremendous show. And thanks to the judges who so patiently listened to all the delegates, the guides who mentored the participants and the delegates, the coordinators who ensured it all went well, the audience, and last but not the least, my team members. Of course, Mr. Shakti Rajan, the IT manager at IMO headquarters in Chennai, and Mr. Ratish BK from the IMO Kochi campus for keeping the IT aspect of this going, which was very critical. Mr. Sanjeev Mehra of the Institute of Marine Engineers for his constant support in matters of publicity. Now, the timings and details of the further program for the next weekend will be conveyed to all on finalization. Till then, take leave of you all, और फिर मिलेंगे सर break के बाद after break open.
Dr. Saxena has something to say.
Yeah.
No, nothing particular. Just want to compliment all the delegates who had put in a lot of work today and yesterday, and of course the guides which have guided them, and the coordinators, and of course the core committee, and more importantly Rajiv Nair, okay, because I think this is an event well done, so we must compliment him. Yeah, so I thought, I must compliment all. Gone very well, and we can see especially the students have put in tremendous amount of efforts. Of course, I mean at their level, we can always expect things which are not 100% right, but at least they have tried, so that's a big thing, that's all I wanted to say. Thank you so much, and thank you for giving me this opportunity. Yeah.
From my side, I think Dr. Saxena said it all. It's all other judges' opinion also the same. I mean, the delegates did very well, and thanks to the chair and thanks to the coordinators.
So, I see Mr. Iqbal Khatib is there. Mr. Khatib, any comments, sir? Any observations?
Mr. Marutra has got his hand up.
Oh, sorry, sir. Mr. Mehta, sir. Sir, we can't hear you.
You are muted.
You are mute, sir.
No, there's something wrong.
You are not audible, sir.
I'm able to hear him, sir. I can hear you.
Achha, you can hear? Okay.
I can also hear him, sir.
I cannot hear.
Very surprising, because some can hear, some can't hear.
He has no words to say.
Mr. Mehrotra has got some selective audience.
Okay. Sunil, please repeat. Sunil and Mahesh, please repeat what.
Yeah, I'll repeat. Speak slowly, sir.
I think he's still speaking. The lip.
Sir, I will repeat what you are saying. Sir Dilip Batra is thanking IMU and Dr. Yogmala and all the judges. Sir, you can continue. I'll repeat after yours.
My God. This is like IMO, huh?
The only thing is, I hope he's not talking in Singaporean or Chinese.
Anyway, okay. So, any of the coordinators want to say anything? Mr. Badhan? Anyway, okay. Then we meet next week. The timings and details will be.
I think Mr. Mahesh was saying something.
Mahesh, anything?
No, sir. I was just saying that I could hear Mr. Mehrotra.
This is selective.
How can it be? The IT person, can he explain what is really happening?
Next time, G, you get a translator from Singaporean to English.
Something unexplainable it is. Somebody can hear, somebody cannot hear.
It's quite right. Okay, sir. Thank you very much. Then
I'm sure we'll find a technical reason for this somewhere.
Yeah, it's very intriguing.
So you can refer it to the technical committee then.
Yes.
Yeah.
Thanks a lot.
Right.
Thanks, sir.
Thank you.
From my side also, a very big thank you to all the delegates who have been in all the efforts in getting these papers across. Thank you very much.
Yeah. And timings and details will be communicated for next week. Okay.
Thanks to everyone.
Thank you, madam.
Thanks.
Thanks everyone, sir. Take care. Thanks, madam.
Thank you.